Guten Morgen. Ich freue mich sehr, ich habe gerade gelernt, ich habe die Ehre der ersten Worte, weil wir sozusagen heute Gastgeber sind als Microsoft. Ich freue mich sehr, Sie alle hier bei uns unter den Linden bei Microsoft in unserem Atrium begrüßen zu dürfen. Ich hoffe, Sie sind alle gut hergekommen. Trotz des Berliner etwas grauen Wetters haben wir heute eine bunte Veranstaltung, hoffe ich, für Sie zusammengestellt. Seerene hat das alles organisiert und wir stellen sozusagen nur die Räume. Ich freue mich auf ganz viele interessante Diskussionen. Ich glaube, was es heute aus meiner Sicht den Tag ausmacht, ich durfte schon mal bei einer Veranstaltung dabei sein, ist das Netzwerk. Darum würde ich mir wünschen, dass wir das alle viel nutzen, die Pausen auch viel nutzen, aber uns auch durch die Vorträge inspirieren lassen. Und ich freue mich auf den Tag mit Ihnen gemeinsam und hoffe, Sie haben hier bei uns in den Räumen viel Spaß. Und damit übergebe ich sozusagen an den zweiten Gast.
Auch herzlich willkommen von meiner Seite. Ich mache sehr viel im Bereich Software-Transformation. Ich glaube, das ist Das ist neben der Elektromobilität die größte Transformation, die die Industrie in den letzten 50 Jahren gemacht hat. Wir brauchen neue Ansätze, wir brauchen neue Netzwerke und deshalb freue ich mich, dass alle gekommen sind, um dazu einen Beitrag leisten zu können. Herzlich willkommen.
Ja, ich wünsche uns einen klasse Morgen und möchte mich an erster Stelle bedanken bei Microsoft, dass wir heute hier zu Gast sein dürfen, an unseren Langzeitpartner Roland Berger. Vielen lieben Dank, dass ihr auch dabei seid. Und ja, dann wünsche ich uns einen klasse Tag. Und kurz zu meiner Person, Marc Hildebrandt, Gründer der German Deep Tech Group und Seerene ist Teil der German Deep Tech Group. Danke.
Auch von meiner Seite herzlich willkommen. Johannes Bonet, mein Name. Ich bin Gründer von Seerene. Es ist toll, mit diesen Partnern sowas auf die Beine stellen zu dürfen. Es ist toll, dass Sie gekommen sind. In der Vergangenheit haben wir schon einige dieser Konferenzen gemacht und was mich da immer sehr beeindruckt hat, war, dass es einen offenen Austausch gab. Also hier sitzen ja Unternehmen, Repräsentanten von Unternehmen, die auch in Wettbewerbskonstellationen sind natürlich, aber es ist eher das Motto, wie kann man gemeinsam Dinge voranbringen und eben mit offenem Visier auch Herausforderungen ansprechen und gemeinsame Lösungen andiskutieren. Und das erhoffe ich mir auch von dem heutigen Tage, dass solche Art von Diskussionen stattfinden können.
Bitte heißen Sie willkommen Professor Dr. Jürgen Döllner vom Hasso Plattner Institute.
Yeah, very good morning to everyone. I guess we will have my slides. I'm Jürgen Dollner. I'm with the Hasso Plattner Institute for Digital Engineering at the University of Potsdam. I'm a software engineer, mathematician, and I like to work on to do research in the analysis, design, and construction of complex software systems, in particular related to computational geometry. Today, I will talk about a more general topic as an introduction here. It's always a good occasion to summarize a little bit my opinions and my views on how software engineering is evolving, especially in the time of generative AI. Let's start. Generative AI is something that changes software development in a fundamental way. It's not an incremental way. So it's interesting because there are signals that this might imply a kind of end of programming. Sounds weird, but I will explain it a little bit in detail what this actually means. So it's also possibly a radical change to the software development as we know it for decades, yeah, starting in the 50s when software engineering came up. We are so used to the way of, we are so used to the tools, methods, and thoughts in software engineering that it's a little bit difficult to think about a different approach. It's always good to have a kind of comparison, something similar that happened before. So the printing press was something similar, compared to similar to generative AI. It, for the first time, it provided a kind of democratization of knowledge. Books, sheets of paper, whatever, could be printed in a radical new way that was not foreseen. So it's always good to see what actually happened then after inventing the first printing press by Gutenberg, for example. It created a whole new industry, and it changed completely the way, for example, books are produced. So this is a similar situation I currently do see regarding generative AI and software development. The landscape of software engineering, we all know there's a bunch of practices around, especially in the last 20 years, it became more agile, more iterative, more in a way more deeper regarding the scientific foundations, but for example, consider object orientation. Yeah, in the end of 90s, consider agile development, any software methodology, consider formal languages like unified modeling languages. All this helped a lot, is helping a lot every day. But there's one key characteristics here. It's all human-based. It's human-centric. Yeah, it's good for analysis, design, implementation, deployment, but always from a human-centric point of view. That is, the ingredients are basically the human logic and the way humans solve problems. Also, how we understand problems. We are quite limited regarding our hardware resources. And there's a kind of predominant procedural thinking. And in general, we are bound to the human dimensions in our logic, in our thinking. So this is reflected in all kind of development tools and methods. So there are some limitations, maybe many limitations. In particular, it's the scalability. If your program is small, maybe most likely you can solve it. But as systems grow, all your methods will somehow fail. It's a proliferation of artifacts that causes this limited scalability. The complexity is increasing, especially regarding legacy code. Produced, generated over many, many years, time-consuming and non-deterministic development process also contribute to this, to these limitations. This is all known as the software crisis, and interestingly, it all was observed and clearly grasped intellectually 68 in a NATO conference on software, and this was a place where for the first time the expression software engineering was coined, and as well the software crisis. At this conference, and I really can recommend to read the original PDF, it's available in the internet, it's a summary of this conference, I don't know, it's about 60 pages. If you don't know that this document comes from 68, you could believe that it was written recently. Yeah. So here they recognized for the first time complexity and difficulty in software development, and this is something I used to show students when doing introduction to software engineering that it's not a mathematical problem, it's not a formal problem, it's related to the way humans speak about problems and think about solutions, and then during typically a long process, maybe months or years, they develop technical artifacts about or for and still not really precisely defined or described situation or problem or what is the cause of the development. So the software crisis still is there, and now a little bit spoiling, there's an end of the software crisis, at least at the horizon. Yeah? Why? It's generative AI. Programming languages are languages. This explains in a very short way why large language models are so powerful. Programming languages have even a more strictly defined syntax and semantics. They are very predictable in a way, and coding standards and convention enhance the learning required for large language models. So most important, programming languages are languages. This is why we can apply the whole tool set of large language models to the domain of software engineering. Especially large language models trained on code seem to be extremely powerful, and most of you have, I'm sure, have tried several times how good the code is when you ask, for example, ChatGPT to solve something tricky. Yeah, this is one of my hobbies now. Whenever I have to wait on a bus stop, I ask ChatGPT to do something really difficult for me, and I'm always wondering how good it is. Yeah. By the way, ChatGPT regarding programming capabilities passed all the exams of my lectures. Yeah, so it's a really good tool, and we have an enormous bunch of information. We have systems like Stack Overflow or countless ticket systems industry applies. So we have a kind of synergy because structured data in our existing systems feed large language models based on sequence modeling, and so we can learn from both the code but also from the context given by natural language. There's an interesting paper, you might want to read it once you have a lot of time. It's about a cool phenomenon. It's the naturalness of software in a nutshell. Software written in some programming languages has the same characteristics like all other documents written in other, for example, natural languages. There is not a real difference because programming languages are complex, flexible, and powerful in theory, but the programs, I cite this conclusion here of the paper, that real people actually write are mostly simple and rather repetitive, and thus they have usefully predictable statistical properties. This is a key finding of years ago that explains why everything works fine. Yeah, it's the naturalness, the utterances you write down with programming languages are not very different from the utterances you apply when you talk to other people. So all this will transform the programming practices. As we know, software developers spend a large part of their time on all these typical tasks like design, coding, debugging, redesign, testing, as well as maintenance and refactoring. And in these domains we can automate. So a generative AI will shift our focus away from these traditional tasks towards specifying what a solution should do and not how to implement it. Prompts, for example, is something fundamentally new. They are meta-information that serves to derive automatically code. So it's maybe worth to it's good to think about how can we systematically manage prompts in the future written by our experts, and based on these prompts our systems will be produced. There's of course a large potential in this human-machine collaboration, a symbiosis between human insights and the speed of AI and the precision, because generative AI produces, statistically speaking, code that is much less error-prone than humans can do. The high degree of quality is impressive. It typically has learned all the best practices, and so we can reduce the likelihood of errors. And of course, the time required for doing the actual coding is neglectable in the future. Imagine that doing the implementation has not any more time budget. It's 0 seconds or 1 second, depends on how fast your data center works. So there's also a paradigm change. I call it software on demand. We are used to have a plan, to sit down with our colleagues, to have a strategic meeting, and then to work on our future software system that should solve some problem. But what if this software could automatically be generated within a controlled environment and for a specific context? Then we could generate the software on demand, that is just in time. There would not even be a system anymore maintained and stored like today. The software would be generated only for a fraction of a second once it is needed. Exactly when a service receives a specific request, it will produce, I would even say, it will produce a corresponding software system. So there will be a decreasing need for developing general, all-encompassing software systems in advance, when specific software systems can be derived at any time, at any moment. By the way, this happens with ChatGPT when you do exploratory data analysis. Just upload an Excel sheet, ask something that makes sense. What happens next? ChatGPT interprets your request, generates Python scripts using some exciting middleware systems. It always knows what to use, writes the script, executes the script on your data, receives, takes away the results, and gives you back as a download link the result file. So this software is just produced for 1 second, and you never will look at it. I sometimes do, because I'm eager to know how it works. Yeah? You can also receive, you can tell ChatGPT to give you the source code. So we have an enormous speed of efficiency. We can handle better complexity, especially when it comes to complex algorithms. Yeah? We have a kind of continuous learning, and something that still at the moment is not on the radar of most people. We will do genetic programming. That is, if we can neglect coding time, we can produce hundreds of millions of variants of a software to see which one is the best. And this is how evolution worked and works. Yeah? You just try. So this endless variety of codings to find an optimal solution will be possibly the most powerful solution strategy. We will redefine roles in software development. As a traditional software engineer maybe becomes more a strategic partner and supervisor, and we will definitely focus to an extraordinary amount on correctness and reliability checks. So this will be the central task within 10 years in software development, in my perspective. Yeah? Manual coding will decline. And we of course, we have to improve our skill sets. There's a need for oversight for explainable AI, and system design expertise and ethics becomes an issue. Just to give you one idea about, or some ideas about how AI-adapted programming techniques and tools could look like in the future. So what will be different? We all know high-level language, we are fine, we have learned this in our studies, and it's all good for humans. Yeah, we tend to give variables good names. Yeah, because and sometimes you discuss with your colleagues about the right name. Imagine AI does not rely on that, doesn't need a self-explaining name. So generative AI could leverage patterns and structures that are efficient for AI algorithms, but they will most likely not intuitive for humans. So this way we can optimize computational efficiency rather than the human comprehension. Also, it will allow us to produce optimized code. Maybe we will not need at all high-level programming languages anymore. You can just output machine code that is highly optimized for the specific hardware. We can even use completely different ways of generating code. For example, self-modifying code that modifies itself during execution. Yeah, this is a little bit related to genetic coding. And non-instructional code representations. For example, an enormous graph that you never will have a look at it, yeah, because you would become nervous. Maybe it's so large that you could not even see it at once, yeah, at a glance. All these are potentials that we are faced with, and I'm so eager to see how all this will work soon. For example, the ultimate risk processor, I like it because it's so cute. Imagine what instruction set do you need, and the theoretical correct answer is one instruction. It's a combined instructions, subtract, test, and jump. This is the ultimate reduced instruction set approach. With this combined instruction, you can implement everything that can be implemented. This is proven, yes, it's yet a long time ago. So this is this command stj, and it subtracts two variables, and if the first one is smaller than 0, then it jumps, otherwise it continues. Yeah, that means this machine code will not have an encoding for the instruction type. You can just skip it because there is only one instruction. Yeah, imagine humans would not like to work with that. Yeah, because we get crazy when we have to program based on this minimalistic instruction set, but AI can do, and AI is quite fine with that. Also, the system architecture and modularization concepts will change radically, so humans will mostly focus on the high-level architecture and the interfaces. APIs, application programming interfaces, become the critical aspects in an AI or generative AI system, because this is subject of an explicit, basically strategic, sometimes political design. For that reason, humans will concentrate on these parts rather than on how to implement modules. Modules below a certain complexity are best candidates for being generated automatically. This is done, for example, by software analysis. It can scan your system and then give you a first roadmap towards what modules should be first candidates for being replaced by generative solutions. And other modules, interestingly, this is my current research, it's related to current research in my group, you can sometimes replace complete subsystems by a black box, and inside this black box there is a large language model or a multi-model large language model. So your system partially will use modules that are just trained black boxes. You never look inside, but it works. So it's also a critical aspect, yeah, of course, yeah, because how to make sure that it does what it is supposed to do. But this is a fundamental change as well, so we can collapse sometimes the implementation of systems into these boxes. And we should have a certain kind of attention. Yeah? We should be very aware of these radical changes, because sometimes change appears, yeah, on the sky, and you don't realize that this is a change, yeah, and it's maybe a radical change. Yeah, this is the last slide. Thank you for your attention.
Thank you, Professor Dr. Jürgen Döllner of HPI. Please welcome the next speakers, and it's a triple feature this time. First time in our little history. We have 3 persons speaking on one deck of slides. Please welcome Dr. Zora Slavik, Senior Project Manager of Bosch, Dr. Matthias Burger, Director Cross-Domain Computing Solutions of Bosch, and last not least, Dr. Johannes Bonnet, CEO and founder of Seerene.
Yeah, thank you very much for the introduction. So, today we want to talk about software production. But first, let me just show you our domain, where we are coming from. So we, from Bosch, come from cross-domain computing solutions, assisted in automated driving. And what is there? We do have a big driving stack with comfort functions, also with safety functions like the assisted family, emergency braking, and we also have a big parking stack. Same here, park steering control as comfort functions and also some safety functions. Both need, of course, video functions. Because of that, we have a big video stack. For example, 360-degree bird's eye view, I think you all know that, and also front cameras which help us to classify objects. Should also not forget all the services, like most are related to maps, localization, planner, road conditions, and so on. So now the point is, how do we bring this together in a that was one too far, so one big. So in a large-scale program. And this is just a value stream of a program, of a typical program at others. So we do have the driving stack with different software integration steps in between. We also have a parking stack, the video stack, as I showed before, and we have to bring it together to a complete software. We should also not forget the basis software. Here we use the tools of ETAS, like AUTOSAR Classic, AUTOSAR Adaptive, and also middleware from ETAS, so the ROS system. And then we bring it together to a complete software. So additionally, of course, customer also have some functions, so we get software deliveries from the customer side and some third-party software, also from the customer. So this is the entire value stream of a large-scale program, and the question is, how can we improve that? How can we continuously improve it like we know it from past, from hardware manufacturing, that we come to a continuous integration, continuous deployment program, and not to a, I don't know, somehow big bang integration at the complete software. And so what we know from past, as I said, at Bosch is hardware production. We have, since decades, international production development networks there. And this is a task, I think, which was a lot of done in past. How can we optimize such a development network? And I just want to show you the well-known lean approach, how we normally do that. The first is we have to identify value. So in our case, that is the productivity. Normally, you start with some monitoring improvement KPIs on which you then can bring the productivity forward. So the second step then is we have to visualize the integration flow. That is what I already showed you. But additionally, we also have to measure the lead time, that we know where we have space for improvement. The third step then is create flow, what we call the Gemba walk. So really go there where it happens, where is space for improvement, inspect and adapt, and then remove any blockers. So once you have that, of course, then you need a product-centric development and communication structure, which you have to establish to manage such a big program. And once you have emergent practice, you normally enter it in a sort of standard. So if you would do it in the way we do it decades in hardware production, and this is exactly the way we started, then it looks like this. So you have a KPI tree. At the top, there's a result, the productivity. Then you have the throughput side on the left and the quality side on the right. Then you have value stream analysis. This is mainly based on interviews and also some measurements, where then have working steps which have no value add for the customer, so the red dots, and value add for the customers. Then create flow, the Gemba walk in software. This is somehow you have to dig deep in the architecture and identify the blocks where is the most workload in, and then you, of course, have the chance to improve that. And establish pull normally is a sort of platform approach. So with the real target to have a high reuse of common parts. So you assemble it in a platform, the application software components, and from that on you can develop specific solutions for our customers. I think this is also related to our domain, that we do not have only one system. Each customer needs a special solution. We showed that last year. And once you have that, of course, then you have to sustainably anchor it, normally in an engineering process. This is like printed here, so a process library, so that it is a standard, and every other project does it in the same way. So that's how we started, I think some years ago. And then we said, just wait a second, is that the real approach for a software factory? Or do we somehow to transfer this concept, this heuristics, which really work in software? And then we came up to Seerene and to Johannes' team, and they showed us some capabilities which really helped us to change the software factory. And so because of that, I'm really anxious to see what Johannes will show us next. And then after that, Zora will show how we are doing this lean approach in software today.
Thanks, Matthias. Yeah, first of all, I'm personally kind of proud to be part of that journey and to have that collaboration with Bosch and cross-computing section, where all these very interesting software systems, what I think are being built, ADAS, the smart things that drive the car. And yeah, so we are collaborating. We are also learning, by the way, in that kind of collaboration, because we see the industry need. And like Matthias said, it is yet an unsolved, or you cannot Google and find a good solution how to transfer, how to measure hardware production into the software production world. And let me see, where?
What's the big one here?
Okay, yeah. So if you try to Google lean manufacturing, right? So this is hardware production, and there are KPIs, and all these approaches, yeah, are not from today. They 1980, so lean manufacturing, Toyota management system. This is where all this began. In a big major stream to be state of the art in doing hardware production, measuring continuous improvement processes, establishing all that. And as Matthias said, this is not one-to-one easy to copy. But if you look at what kind of KPIs are being used in hardware production, there are some which we took into the focus. For example, if energy consumption in hardware production, how much material is and costs of material being used to produce the products. This is essentially looking at the scarce resources in the production process. And with Seerene, we focus on scarce resources in software production. And if you look at the industry, and by the way, this is not only automotive, this is the same in banking, insurances, manufacturing, retailers. They are all more and more becoming software companies. Why? Because the competitive edge is driven by software. And sure, you can buy standard software systems for the HR finance processes, but to win or to keep up with competitors, you need to integrate smartness into your products, into your processes. And that's why many organizations have a large software factory under the hood. And what we see is that the people or the ones responsible for that, let them be CIOs or CTOs or whatever they call them, right? There's a variety of names. They started with a journey. First, it's about having the people to doing that, right? Capacity. Then the tools in the place in the software factory. Then the methods doing that. Nowadays, a lot of agile in the automotive or in general in the embedded world, it's the V model, but still trying to be agile within the V. And now, and this is good for us, right? But now they understand it's also about systematically getting better and looking at the scarce resources, being efficient, cost efficient and fast in the production process. And this is not a nice to have anymore. It has become a must have, right? And so it's about measuring, identifying, improving regular in a cycle. And all this as a data-driven approach. And if you look at the methods, the approaches that are in research and also in the industry today, how to tackle that, it's not yet that far like you would wish it and like it is in the hardware production. For example, the basic approach, and this is where many of the organizations stand today, is looking at the produced material, right? If you build software, software is made out of code, and what organizations do is measuring the quality of the produced material. So it's measuring like what comes out of the factory. It's MISRA violations in automotive, right? QAC, coverity, all these kind of metrics, code metrics. But this is definitely not enough to get a grip on the process, on the software production process, because it's just measuring what comes out of the factory. And if you try to look for approaches to look into the software factory, you would probably find two things. One is DORA, right? This comes from Google. Google has a very strong reach. That's why it's very prominent. And DORA means how fast can requirements end up in running software. More precisely, it's a little bit less. It's just, as I depicted here, it's just about the typical gap between coding something, introducing into the code, and then bringing it into a running system. So this is where DORA puts a focus on, and we speak with a lot of organizations, and if I ask them, okay, what do you already do? They usually say something, yeah, we're trying to implement DORA. So as a first step, and I think it's very good to have that first step, but it's not really measuring productivity. It's measuring a technical bridging of a gap here. And one of the difficulties here from a measurement point of view is that the teams, the developers, need to change their way of working first, and then you can measure. So teams need to annotate data in tickets, Jira, for example. They need to annotate Git tags. So this is a technical thing that says now it goes into production. And so from a measurement point of view and also from a larger scale organization point of view, this is bad news, because it means first you need to bring into your big organizations hundreds of developers saying, okay, change the way of working first, and then we can start measuring, and then we can start improving, right? This is the big pitfall of that. The next approach you would probably find if you try to research in the internet or literature and how to measure productivity. This comes from Microsoft GitHub, the space approach, but it is purely survey-based. So it's a lot of questions to developers, and most of the questions start with like, how do you feel about this or that, to get some insight about how the organization works, because it's human beings and they tell you what works good, what works bad. So this, this is not, it's data-driven, right? But you cannot do this daily. Otherwise, everyone would just fill out surveys. You do that once a year maximum, right? Bad news, that's it. That's where measuring software productivity stands today. So it's still in its conceptual infancy, and our aim is to bring that to the next step. And I already said hardware production, focusing on scarce resources, software production, that's what we're doing, and the scarce resources are typically the hundreds of developers that you are paying, because this is where the money sits, right? You're also paying for testing, you're paying for requirements, but the big portion of money is where people are working and producing. And by the way, I would also have a lot to say on top of what Jürgen Döllner just said, right? So it's reforming code. So you will still need developers to reform over and over the code. And this is today and the next years, this is the bottleneck. The power in the organization of developers who take requirements, convert it into code, and then bring it into the systems. And that's why we put the measurement focus here. And big organization also means workers' councils. You need to be careful if you measure people information. That's why we, for example, first thing we learned, everything fully anonymized. So it's not possible to drill down to individuals. And it's not necessary, actually, but you can see how much power is flowing, how much money that you invest is flowing. And then we can measure from the large amount of money you're investing, how much is actually left for creating business value add and how much is lost. And this is exactly what hardware production did with measuring lean and measuring waste in the process. By the way, if you see these city map visualizations, this is the Seerene way of visualizing the amount of code that has been grown over the years. Right? These buildings are code files and organized in these code cities. I just mentioned that because Zora will also show some maps. This is then means grown software systems. And it, by the way, again, hardware production, software production, one difficulty in software production is that you produce something that you cannot see. You could print out code, but if you would print out the code that sits in the car, right? I don't know how big the paper stack would be. Probably 400-floor skyscraper, something like that. So it's not possible for a human being. That's why we use that kind of visual metaphor to make it tangible, and also to be able to communicate about this. And one thing we learned additionally on our journey together, also in other customers' situation, it's not enough to say we're getting better if we tell the teams, please get better. Because teams are in their operational pressure, right? Continuously improving is something which needs to be driven by top management. That needs to be, this mindset needs to be started top down. The mindset of getting better. And that's why we also established this concept of not only measuring efficiency, for example, in producing one software system, but in a large organization with multiple software systems involved, multiple teams, sitting all over the world, and having one, and everything based on data, that's the key point here, everything based on data that has already been collected. No change of developers needs to be done first, the data is already there. That's where we put so much brain work into it to be able to use what's there already today. That's why we can apply all this to any kind of programming languages, to any kind of software systems, to any kind of organizational, how you organize responsibility in an organization, with scaled agile, with agile release trains, solution trains, or a department. It works because the data is technically has been created yet. The data is code, the data is coding, the data is backlogs that drive that. And here on the left-hand side, you see a typical example of efficiency. And it reads like what comes into this waterfall is the amount of developer time that you pay, right? The budget, the investment, and what is left on the right-hand side, that's what is left for planned value-add creation. And everything in between is something that gets lost on the way. For example, fighting back defect backlogs. For example, having to go into code that where complexity sits so that you're very slow as developers. All these things are lost time, lost money, and they kill the productivity. And good news is, if you can measure that, you can continuously, in small steps, getting better and better and better and convert all this loss into more power of your organization, which means becoming more cost effective and having more power to be faster. And here you see a loss of 80%. It's a typical inefficiency. Sometimes when we go into an organization and measure first time, sometimes we already see like 35, 40%, but that's it. And I'm kind of proud to be in that collaboration with Bosch, because if you look at their numbers, it's incredibly high. So it's a lot of money that they save because you started with data-driven continuous improvement processes a while ago, and I think this is something, if you do that, there's a lot to gain, money-wise, but even more important, speed-wise, and by this, being ahead of the competitors in the business, and we all know industry economy is getting tougher and tougher, right, worldwide. New players come from Asia, US, etc. So my opinion would be it's a must-have. Yeah, and now sorry, now Zora, take over, please.
Thank you very much. Yes, so let's have some hands-on actually. So as you heard, developer time is very valuable, and we want to make sure that actually our developers, or we as developers, as managers, as a company, work on the right things. And we love data, we love facts, so this is why we also want to make decisions based on that. So let's have a look on, again, here the lean concept, and how are we actually doing as a software factory now? Let's have a look. So first of all, enhance productivity. So we want to make sure that we spend most of our time, of our valuable time, on actually adding value. And this is now a new feature from Seerene, or something that we lately developed, about efficiency versus loss. And here we can understand how much time do we spend actually on defect fixing. So this is here can you see this, the dot? So this is this part. How much time do we spend on this? How much time do we spend on ad hoc tickets? So how often are the developers actually interrupted in what they're doing? And this is actually something from a project that started in November 2023. You can see here the effort ramp up. You can see here the Christmas break, so it's real data. And yeah, we can see, I mean, it's still at the beginning, but so far we are spending 89% of the time on actually adding value, creating code. So, and with this, we hope that we can also maintain this. So the next point is to visualize the integration flow. So we have a lot of different sources, a lot of different huge teams that contribute to our complete software. And we need to integrate it together with software development, or we want to integrate it together with contributions from our customers. We want to be there very modular, very flexible, and adapt to what our customers want from us, actually. And so what we have here is our own tool, Metron, and we are using it to measure actually the lead time. So we measure how long does it take from one, oh, sorry. How can I come back? So, okay, great, thanks. How long does it take that our driving team deploys to the customer software or to the next block, including the middleware? How long does it take for parking, etc.? And when we look at, and this is based on our repos, so this is something that happens actually, and it's no watermelon reporting or anything, but it's displaying what's actually up. And this enables us to identify blockers, impediments before they become risks and act accordingly. And of course, as Bosch, we don't want to be only fast, but we also want to have a high quality. And because of that, we started to use Seerene to actually visualize our technical depth, our QSC warnings, the complexity in our code, covariety warnings, all the static code analysis warnings, right? And we actually identified at some point that we had a cluster in our code landscape where we had a lot of QSC warnings. So we started a campaign to reduce these QSC warnings, and the result is what you can see here. So all the green blocks mean that this is how we reduce our QSC warnings. And yeah, we hope that it's not getting red anymore, but we will continue to monitor that. So that's for the Gemba work, and then of course we have huge teams. So we need efficient communication structures. And this is the next part. So we need to make sure that actually we have the right business decisions, so that we understand what's the next value, what's our portfolio, where should we focus our developer time on. Then we need to make sure that we have a robust, solid architecture that allows us to develop these large-scale projects that we usually have. So we need to make sure that all the interfaces are stable and that they match to each other. The zip process, we need to apply it to continuously monitor what's happening in our code, in our repos, and to monitor the lead time, understand it, and act in time. And of course, our organization, we need to manage our changes. We need to make sure that everybody knows what changes, when it changes, and what needs to be done. And after all these learnings, we need to anchor that in the organization. So we need to make sure that not every project needs to start from scratch and to, again, implement all these learnings, have all these learnings. Well, and this is basically how we are doing currently. So we are driving, of course, our business forward. And with these tools, Mitron and Seerene, we really came a big step forward to our software factory. It helped us to identify some issues in our architecture that we could fix so that we can now build for scale and that we can continuously maintain the flow. And of course, we do our Gamba works. So this means we really have the deep insight in what's happening in our teams. And we always make sure that we have the right tooling for that. And this is how we can actually develop our code driven by value. And we designed our whole software architecture and tooling environment to deliver. And we made it in a way that it's built to last. Thank you.
Wow. Thank you, Dr. Sura Slavik. Thank you, Dr. Matthias Berger, and thank you, Johannes Bonnet. Okay, let's move on. Please welcome the next speaker. Please welcome Dr. Joost Bernasch, CEO of Virtual Vehicle Research.
Yeah, good. Oh, it's very loud. It's okay? All right. Yeah, good morning. Yeah, very interesting talk. Data-driven is what I also want to talk about, though this connects very well. And only needs the slides, then we can start.
Bitte.
So there will be a good connection to what you're talking about, data-driven. So it's what I will show a little bit in a broader manner, but I think there might be good connections to that, what you just showed us. If we solve these software problems.
Eine Minute bitte.
So just, yeah, let's use the time a little bit. So my name is Joost Bernasch. I come from now from Austria, Virtual Vehicle Research Center. So I'm since 22 years in Austria, originally from Germany. So I was 12 years with BMW in Munich, from 1989, starting with the big Prometheus project. So driving assistance systems. I built up the driving simulation software at BMW. We developed the headlight, the adaptive light control in the mid of the 90s, so the first light simulation. And in 2004, I changed to Graz, where we built up a research center. And now I can tell you, I think in some seconds, what we are doing. Yeah, there it is. Yeah, I think key technology is really data-driven software development, but also software, hardware, co-design. What we see today in the automotive industry, though we have a lot of problems, a lot of delays in projects. If you go back 5 years or something, it was no chance that an OEM at BMW, that the SOP is 6 months late. So it would be a catastrophic. But today, it's quite usual. Nevertheless, whether it's in the US, partially in China, German OEMs, Rivian, Apple canceled all the project. So we have a lot of problems, often concerning software development, but the overall complexity in the car, though we have many delays in the development. Why is this happening? So we have hardware and software with really increasing complexity. We have not only the development, we now have the operations, so software updates, so we have to cover also the operation. We started with having one ECU for one kind of typical functions, so many functions, a lot of ECUs, so we're earning a lot of complexity, interdependencies between all these functions, so this complexity is really exploding. But we don't have to forget about the classical vehicle requirements, safety, comfort, today the battery, energy management, all the legal requirements coming up more and more worldwide, and also concerning virtual validation to speed up the development, having virtual validation for certain functions. So these requirements, and we will have a big change in the platform, in the computational hardware platform. So the electronic platform is changing a lot. So we're going to central ECUs with some zonal ECUs and so on. And what we will see is a change of how software and hardware is working together. So instead, in the past, we have a tight coupling of software and hardware for some special car, for, let's say, for Golf, Passat, and so on. You have very special solutions, and the intention is to have a loose coupling so that you have as a fast software development, software updates, and you have the hardware development on a different time scale. So we have two time scales which has to be addressed in software-hardware co-design. So in the past, at the start of production, software and hardware just was fixed, and it's running for a couple of years. This is changing a lot, especially in China and the US. So Tesla was a front runner, but now they have the most software updates per month or per year right now. And on the places 2 till 8 or 9, Chinese companies are following, and German OEMs are starting place 15, place 20 concerning software updates. But this will change. So you will have software updates all the time, changing functionality. Even the discussion is, have you all legal requirements fulfilled that the car might still run on the road if you change the functionality a lot by software updates. And how to handle these different cycles. So you have hardware cycles more concerning 3 years, 4 years, and software cycles inside months, even days. We started about 15 years ago with a multi-domain simulation, multi-domain development with almost all OEMs in Germany, all over Europe with the tier 1 suppliers. So we have a long experience in that. And I would like to address 3 development threads which has to follow and which also are playing together. So energy, safety, comfort, all the classical important properties of the car is one important thread. Then software-defined vehicle, all the functionality, autonomous driving, and so on, all the assistance you have today, and they will increase. And the change in electric design, high-performance computing in the car. So if you look at the development process, you have to come from all the requirements, and this should be done more automatically concerning virtual testing. You have to derive more automatically all your simulations and your testing, and then you go stepwise to the real testing. And we have developed a kind of co-simulation which combines hardware and software modules, so you can go step by step into the hardware. It's not one big step, but you can go step by step into the hardware. And then today you have also to look at the system operation, to the software updates, and also data coming from the car again into the development. So concerning data-driven, you have in these 3 development threads, you have a continuous data provisioning of thousands of data sources which have to be managed in every of these three threads. But finally, for certain cars, all the configuration of the data used for these three threads has to play together, that the car is really working, and that you don't have to push your start of production 6 months, 9 months, or even more. So connecting these kind of software-intensive systems, which is a big topic today, but also all the classical vehicle domains, as well as the new high-performance computing, which is coming up into the cars. These are the challenges of tomorrow. And why is data-driven so relevant? If you just look for one car, you have certain software version, you have some additional settings which you might buy on the market as additional hardware and software, you have a certain generation of hardware, and this works fine for one special car. But if you have millions of vehicles, countless of different software versions, software updates, you have certain hardware generations. All these three threads are influencing each other, yeah? And you really have to manage this, and if a bug is occurring, how to address this, and will this influence other versions and other configurations. So the task is really quite big. And we started already 10 years ago, in the last 5 years very intensively, with a project, how the future engineering, so we are in the strategy steering board of some OEMs discussing how will the development, virtual development, with all these aspects, what kind of properties will drive the development in the future. So future competitive and process performance is very largely dependable that you have thousands of data sources. So the OEMs we are working with, we are already connected hundreds of data sources for the development. You must address the context of the data sources so that during all the development you have a very well-defined status of your data configuration. You must know what you are working with. The engineer, the management should rely on the same data status for decisions and for the development. Then, as I already mentioned, automated simulation, automated validation should be derived, maybe with more generative AI, as we heard in the morning. Automated simulation should be derived out of these data because you don't have all these engineers to make these complex simulations. It must be more automatically, and you must be aware of what kind of data you have to use and have been used. Also, you have to document this for legal issues. And systems engineering is getting a big task, model-based systems engineering, because of the three development threads I have shown. They have worked together and they must work and it must behave properly in the specific car with all these properties together. So it's very important to have a digital thread, so all of your thousands of data sources, they must be available, they must be accessible. This is not easy if you go into the companies. We have worked with some companies which are here also. This is still a big problem. The traceability, for example, for especially VW, is very sensitive to this problem. You know why. And they have to document all the processes, what kind of software versions, when the decisions has been made on which kind of sources, which kind of data. So traceability is extremely important. And the context of the data, so which data are influencing other data, which data fits together. So the data accessibility and synchronization is a very important task to develop a car in time. Why this is so important? So, a simple example, connectivity, context, and semantics of data. What does this mean? You have really a huge amount of data in every big company, simulation data, ERP, SAP, delivery, parts, everything. So you have a lot of data available and you can sort it in different ways. You can arrange it and present it in different ways. You have data lakes in the big companies and they are really unlucky with the data lakes. Why? Because you are lacking the context and the semantics. Yeah? If you put this together, then you have the information, then you have the knowledge. and to access the knowledge and bring the right data together, the context of the data. This is a key aspect in all tasks of development. So what we have developed in the last 5 years together with a large German OEM and a big software company is a system called Data Context Hub, which tries to help to avoid all the data silos. So there are thousands of data silos in big companies, to bring this together and to make decisions based on well-defined information. And the concept behind that is intake to contextualize the information and delivery, so the application. So we can read in arbitrarily kind of data, geometric data, software, vehicle characteristics, market data, costs, Excel sheets, whatsoever. We map this on a map database where we derive partially automatically based on AI, but also partially based on knowledge engineers. So the big OEMs are having knowledge engineers putting additional knowledge, annotating the data and the context of the data so that you have more and more knowledge in the data, and then you can derive different kind of applications. It could have the engineers, the developers, but also the mid-management, but also the top management, because they can rely on the same configuration of data. And this is often the big problem, that some developments or some decisions are on different data inside the big houses compared to other groups. So this works in a big OEM since 3 years, even for very, very large tasks. And I think in the future, these controlled usage and access to data is getting even more important. You may know Catena X as a big project and activity. Catena X allows, based on the data, that on a defined way, you interchange even trusted data between OEMs and Tier 1 suppliers, for example, and all Tier 1 suppliers are pushing, all OEMs are pushing Catena X at the data interchange, trusted data interchange between the OEMs and the Tier 1 suppliers. And in order that this might work really properly, you must have a base where you really can access and control all your data and bring the appropriate data together. Yeah, some examples what we have did additionally in our research center. We have been founded 2002, so it was the start of a research center for virtual vehicle development, growing up to 300 people right now, working all over Europe in a lot of European projects in Horizon 2020, Horizon Europe. And now we have just finished financing for the next, or partially financing, of course, only for the next 10 years. So we are very active in automotive, rail, but also some other domains, primarily in Europe, but also some customers worldwide. We are working with Apex AI. They have, Jan Becker was at Bosch at that time. And we are working with him very closely together, for example. So as I said, we developed this tool where you can integrate different kind of data, and which is important if you import the data from time to time, every day, every week, depending on the original system, which remain the original system. Then you also import the access rights. So who can access which kind of data? So these access rights are also built into the map. We have a very robust graph structure in some performance measurements compared to really large software companies. We have shown it's really very, very efficient. And we are right now for a big OEM combining this with Gen AI methods that you can analyze, and like a ChatGPT for all your internal data, you can ask inside the OEM and can analyze accessing all your data if you have the access rights, also with the explanatory way. So this is just being built up and will be demonstrated at an OEM next month. So arbitrarily data inside from the OEM, also accessing additional data from the outside if necessary. This is all building up in the data context hub, and together with Gen AI applications, you can use it as a test generation, simulation generation, even for marketing, for the test engineers, development engineers, for the management. So the big advantage is that on one defined data status, all the application, all the people can access on the same quality way. Some other activities concerning automated simulation, automatic system simulation. So based on a functional architecture each OEM or each product developer has, for example, like enterprise architect or system architect modeler from ANSYS is now on the market with System L2. And accessing the data with an appropriate system, you can import all the information you need. Test cases, simulation models, configuration data, and then you can derive automatically all the complex simulations, also what Bosch has shown. You can automatically configure all the simulation, putting in a co-simulation complex system together, and this could be done automatically. Or we have shown for an OEM to do this automatically. You have to define KPIs. It could be the assessment of the KPIs, could be also AI-based, it could be human-based, so that you see what has to improve or what has to be designed. But to automatically derive these kind of information and assessments, this will speed up the development efficiency. Simulation is always a big topic, big discussion. And how credible is a simulation? What is the quality of the simulations? This is a key question. And there was a big European project with majority of also German companies in the last 3 years. And there was derived methods how to assess the quality of models and the quality of simulation. And the result of the project is now being prepared for an industrial standard with an Intex group. It will call Model and Simulation Spice, a little bit similar like A-Spice for the software. And this will enable to assess the quality of models and simulation in the future. And this is very important for virtual validation. So this is an example where you see that in the co-simulation you can combine and configure automatically a lot of different simulation models. So the environment, the crash behavior, the different kind of sensors are simulated, the safety controller for the airbag, and you can run thousands of these kind of simulations and can change some data. Yeah? You can change if you use a more expensive sensor, for example, or if you use another software for the airbag controller or anything else. And then you can assess your KPIs and can run automatically these kind of complex software designs. Some years ago, we had the first automatic driven research car in Austria. This is on the Formula 1 track in Austria. We are running there, but also on public roads. It has a fixed, of course, EE architecture, but we change the software quite often. We are working with Apex AI together, relying on AutoWare. And what we did is that the development in a virtual environment could be put into the car inside 30 minutes. So it's a mirrored environment, what is done in the car and what you are doing in your simulation. So this could work very closely together. And we have been part at the Robo Race in the last year. So it's an autonomous racing of robo cars. And during Corona times, it was only in the racetrack on Las Vegas. So all teams are sitting at home in their garage, making the software, improving the software. The software has been loaded up to Las Vegas, and then the autonomous car race was there. Every prototype value $1 million. And the engineers never touched the car. They only make the testing in Graz for our team, load up the software, and then the race took place. And this is the kind of development you would like to do with software and hardware, independent on the hardware availability and driving really around. Yeah, let me summarize. I think for future engineering, really key enablers are that you can handle the complexity of these three complex development threads I have shown, the collaboration inside the company, because more and more system-oriented the functionality is compared to the past, and also working together with the tier one suppliers to adapt to changes. So we have a lot of changes every year in requirements, and we need a different culture, mindset, that you really work with data, that you use traceable data, and with a data-driven development, including automated engineering, software-defined vehicle, and a new architecture on the electric hardware, you need to use new methods, and I think a reliable data-driven method is very important in this way. And yeah, you should be open to new methodologies, and don't say, oh, I'm so busy, I don't have time to improve. Thanks a lot.
Thank you very much, Dr. Jost Berger. So please, before we pick all of your brains and we discuss together, let's grab a coffee. Christian Berger eingeführt. Hi. Bitte kommen Sie doch alle dazu. Wir brauchen hier jede Person, denn jetzt geht es um eine Diskussion. Ja, wir haben hier einen wundervollen Pool an sehr hohen Kapazitäten. Einige Koryphäen sind sogar dabei. Und wir wollen Sie und euch alle hier involvieren und eine Diskussion starten. Um das Ganze richtig in Gang zu kriegen, haben wir hier einige Experten auf der Bühne. Wir werden das hier in Deutsch machen. Deutsch und wer möchte, gerne per Du ist das Grundprinzip. Das hat Professor Christian Berger, der CTO von Datev, beim letzten Mal eingeführt. Ziemlich rigoros und er hatte recht. Die Diskussion läuft dann wesentlich besser. Und ich möchte zunächst mal hier vorstellen, wir starten erst hier auf dem Panel und würden Sie dann integrieren. Wir haben ein Mikrofon bereit und würden, wenn Sie uns signalisieren, Sie dann auch mit dazu nehmen. Zunächst möchte ich Ihnen vorstellen, wen wir hier haben. Wir haben Karin Schweizer, Director Digital and Application Innovation von Microsoft. Wir haben hier Wolfgang Wukisiewicz, CEO von Consulting for Drive, das ist IAV Consulting. Last und least ein Unicorn, Dr. Stefan Poletner, CTO von TTTech Auto. Vielleicht bringt es das Ganze in Schwung, wenn ich die Panelisten bitte, sich kurz vorzustellen. Karin, können wir mit dir anfangen? Erzähl uns mal ein bisschen was über dich.
Na klar, sehr gerne. Genau, Karin Schweizer. Ich habe ja vorher schon begrüßt, dementsprechend also Microsoft, auch schon relativ lange in verschiedenen Bereichen gewesen. Ich leite inzwischen den Bereich bei Microsoft Deutschland, wo wir mit allen deutschen Groß- und Mittelstandskunden arbeiten, zu allem, was Entwicklungsthemen angeht, Entwicklungsproduktivität, Applikationsthemen, Applikationsmodernisierung, Cloud-native Entwicklung und natürlich, wie kann es anders sein, AI beschäftigt mein Team auch sehr stark, mein Bereich, also alles, wo AI in Applikationen und Lösungen zum Leben kommt, da arbeiten wir eben auch mit vielen von Ihnen und anderen deutschen Großkunden über die Industrien hinweg zusammen.
Darf ich, Stefan, dich bitten,
ja,
kurz was über dich
gerne.
sagen?
Also Stefan Poletner. Ich habe einen langen Industrie-Background, vor allem im Automotive-Bereich, aber nicht nur dort. Wir haben vor 25 Jahren, bisschen mehr als 25 Jahren, das Unternehmen TTTech gegründet und das dann breiter aufgestellt. Das heißt, wir liefern heute in der gesamten Gruppe Lösungen für Luftfahrt, Weltraum, also Ariane, NASA, für Baumaschinen, Landmaschinen, industrielle Anwendungen wie Windturbinen und sind vor allem auch im Automotive-Bereich tätig, wo wir schwerpunktmäßig Software-Defined Vehicle, High-Performance Compute, rund um das Thema ADAS, Plattformen machen. Und wir haben eigentlich gestartet, die Firma damals 5 Mitarbeiter, also zu 5 haben wir sie gestartet mit dem Thema Safe Computing, Safe Communication. Das war so die Kernidee, mit der wir gestartet sind. Und wir haben das dann eben weiterentwickelt in diesen unterschiedlichen Industrien und sind heute so insgesamt so knapp 2500 Mitarbeiter in der Gruppe.
Mhm. Dann darf ich noch Wolfgang Wukisiewicz bitten. Wolfgang, erzähl was über dich.
Ja, Name Wolfgang Wukisiewicz, von der Phonetik her, in der Form können Sie mich in Österreich zuordnen. Bin aber jetzt schon in meiner Laufbahn 33 Jahre im automobilen und im Powersports-Bereich unterwegs und das vorrangig hier in Deutschland, in den USA und teilweise in Asien. Seit Beginn diesen Jahres dann in die Geschäftsführung der C4D übergetreten, vorher 10 Jahre bei EAV in unterschiedlichen Führungspositionen, Bereichsleitung, Powertrain für Produkte und für Services und darf jetzt die Geschicke mit meinem Kollegen Michael Junger bei der C4D leiten. Die C4D ist eine Unternehmensberatung oder eine Beratung Consulting for Drive mit einem Schwerpunkt im automobilen und im Mobilitätssegment. 2014 gegründet, auch mit 5 Personen, jetzt sind wir 90 Personen. Wir beschäftigen uns sehr intensiv mit dem Thema Strategie und Technologie, haben systemisches BMO in der Form auch ganz weit vorne auf den Aktivitäten Lifecycle Operations Management, Due Diligence und natürlich auch all das, was dann im systemischen BMO auch zu tragen kommt, wenn der Mensch in der Form immer noch Teil der Gleichung ist mit dem Thema Change, Transformation, Taskforce, all das, was sich in so klassischen Projekten dann auch nochmal ergibt. Ich freue mich über die Einladung und dann jetzt auch schon auf die Diskussion.
Vielen Dank. Ich möchte anfangen, wir saßen gestern beim Speakers Get Together, was Mark Hildebrand netterweise traditionell stiftet. Und wir saßen in Borchardt und dachten, wir unterhalten uns über Trump und dann kamen die Nachrichten von der Regierung. Und danach haben wir gar nicht mehr gewusst, es skalierte da mit der Dramatik, die wir hatten. Und das galt auch ein bisschen für die Automobilwirtschaft, die darin auch, also es gab, alle Leute hatten direkt einen Bezug dazu gefunden, was jetzt mit der Automobilwirtschaft passiert und niemand war so richtig selbstzufrieden. Viele hatten auch eher Angst. Ich bezeichne mich gerne als Amateur im wahrsten Sinne des Wortes. Ich hatte einfach Angst um unseren Standort und um das, was wir da treiben und wie die Ingenieurleistung im Automotive-Bereich, ein Thema auch von vielen unseren Kollegen hier, wie die überhaupt noch, wie wir Mehrwerte bekommen und erzeugen können. Und ich möchte mal bitte alle 3 Experten hier fragen zum kurzen Statement. Muss ich mir Sorgen machen, ernsthafte Sorgen, wie schlimm ist es und wie können Sie persönlich Ihren Frieden finden mit der aktuellen Situation und was würden Sie uns allen hier raten? Darf ich?
Ja, gern. Also vielleicht Folgendes. Ich glaube, die Situation ist wirklich besorgniserregend, ist vielleicht das falsche Wort, aber wir sind, wenn man es ein bisschen anders formuliert, wirklich in einem der größten Umbrüche, die wir in der Automobilindustrie jemals hatten. Das ist absolut so. Und da spielen im Grunde genommen eigentlich 2 Elemente hinein. Wir bekommen jetzt ganz stark, wenn ich jetzt da auf die politische Situation komme, es gibt diesen Digital Divide zwischen West und Ost, der ist einfach da. Das ist das eine Element, ja, sei es jetzt durch Strafzölle, sei es dadurch, dass die Chinesen nicht bestimmte Chips aus Amerika mehr bekommen. Also das heißt, da gibt es eine ganz klare Entkopplung, das ist das eine Element. Das zweite Element ist ganz klar, das vielleicht noch bedeutsamer ist, dass einfach China in den Corona-Jahren extrem stark aufgeholt hat technologisch. Die bauen dort sehr gute Autos und der große Profit-Pool, den wir in Deutschland, in Europa gehabt haben, wo sehr viel Profit im chinesischen Markt erwirtschaftet werden konnte, der bricht jetzt weg, weil die Marktanteile, die Deutschen und andere in China haben, die reduzieren sich zugunsten eines lokalen Angebots, das dort gibt. Ja. Und das heißt natürlich, dass es zu massiven Restrukturierungen bezüglich Volumina, Entwicklungskapazitäten kommen wird. Also das ist meine Sicht auf die Dinge. Das ist die eine Dimension. Die andere Dimension, die wir natürlich ganz klar haben, ist das Thema, sage ich mal jetzt Richtung Software-Defined Vehicle, höhere Integration, die ganz stark aus der Halbleitertechnik getrieben ist. Wir haben einfach die Situation, dass wir jetzt High-Performance-Chips bekommen, die ganz viel Software-Workload, die auf vielen einzelnen ECUs aufgeteilt war, sozusagen konsolidieren und gemeinsam integrieren können. Und das ist eine Möglichkeit, die große Potenziale schafft, um Software-Update über den Lifecycle zu machen, attraktive Funktionen ins Fahrzeug zu bringen, die aber gleichzeitig auch fordert, das zu beherrschen in Bezug auf Zuverlässigkeit, Sicherheit im Fahrzeug und dass wirklich da auch ein Kundennutzen da ist. Und diese Gesamttransition, die ist natürlich extrem herausfordernd und bietet aber auch natürlich Möglichkeiten. Also es ist ja nicht nur immer so, dass alles schlecht wird, es gibt auch natürlich Chancen in solchen Veränderungsprozessen.
Das Letztere gibt mir etwas Hoffnung, aber es ist sehr ernst. Darf ich dich mal fragen, Karin?
Ja klar, also gerne einfach ergänzen. Ich habe viel da auch schon gesagt. Also ich noch ergänzen, 3 Punkte. Also klar, wenn man in die Presse guckt dieser Tage, nicht nur aufgrund der politischen Lage, sondern auch was in der Automotive-Industrie in Deutschland passiert, muss man sich Sorgen machen. Ja, Gedanken sollte man sich auf jeden Fall machen, denke ich. Auch eben aufgrund der ganzen Themen, die eben genannt wurden. Und ich denke, es ist aber auch eine gute Chance, um den Schritt zurück zu machen und manche Dinge zu hinterfragen, einfach und neu anzugehen. Und manchmal hilft Druck ja auch, um Dinge zu beschleunigen, die man verändern muss. Und das ist auch was wir jetzt sehen aus Softwarehersteller-Sicht tatsächlich, dass einfach die Diskussionen beschleunigt werden und dass andere Partnerschaften einfach passieren. Also wir arbeiten viel intensiver partnerschaftlich mit großen Tier Ones, mit großen OEMs zusammen, um eben auch mit AI einfach Dinge zu beschleunigen, zu verändern, Themen zu hinterfragen und sehen da schon wirklich super spannende Lösungen im ganzen Produkt-Lifecycle auch, wie Produktivität gefördert wird, wie Innovation getrieben wird. Und ich denke, das ist einfach eine Chance, mit anderen Partnerschaften auch nochmal voranzugehen. Also deshalb Angst nicht. Ich glaube, ich würde es mal als Chance sehen eher und da vorangehen. Und wie gesagt, vielleicht noch ein letzter Punkt, ich fand nämlich die Metapher tatsächlich vorher prima vom Professor Döll vom Hasso Plattner Institut mit der Druckpresse. Und tatsächlich habe ich diese Metapher ein bisschen weitergesponnen, vor kurzem auch bei uns, bei Microsoft, bei unserem weltweiten Kickoff gehört von einem unserer weltweiten Chefs, der eben auch dargestellt hat, General Purpose Technologies wie eben AI, die sich auf viele Industrien auswirken, wie verbreiten die sich? Und AI ist eben auch eine davon, weil sie hat die Chance, alle Industrien eigentlich und jeden unserer Lebensbereiche zu verändern. Und er hat auch mit der Druckpresse angefangen und gesagt, die Druckpresse wurde eben zum Beispiel in Deutschland erfunden, aber profitiert am meisten hat, wenn man so 10 Jahre später geguckt hat, tatsächlich Holland davon. Und was ich damit sagen will, ist, nur weil AI vielleicht woanders erfunden wurde oder woanders herkommt, haben wir als Deutschland mit den ganzen Voraussetzungen, die wir mitbringen, mit dem Engineering-Mindset, mit allen Stärken, die wir bringen, die Chance am meisten draus zu machen. Und ich glaube, die sollten wir ergreifen.
Sehr positiv, vielen Dank. Wolfgang.
Ja, es ist schon vieles gesagt worden, aber nochmal zu sagen, die Märkte werden protektionistischer, das ist ganz klar, das sieht man auch an der Stelle. Und China hat sicherlich die letzten 5 Jahre nicht geschlafen. Ja. Es werden jetzt Geschäftsmodelle ins Leben gerufen, wie zum Beispiel dieses Software-Defined Vehicle, was für mich auch ein Geschäftsmodell ist. Und bei solchen Geschäftsmodellen müssen wir uns einfach im Klaren sein, okay, was benötigt so ein Geschäftsmodell? Und so ein Software-Defined Vehicle oder wenn wir auch diesen DevOps auch anschauen, das Thema Daten braucht Server, ich brauche Cloud, die brauchen Strom, die brauchen Energie. Ja, das sind alles Dinge, die, wenn man sich jetzt hier in Deutschland mal die Situation anschaut, nicht am kostengünstigsten sind. Ja, da müssen wir uns auf jeden Fall Gedanken auch dazu machen. Aber nichtsdestotrotz, wir werden die Fragen der Zukunft werden wir nicht mit den Antworten der Vergangenheit beantworten können. Es braucht mit Sicherheit diesen Aufbruch, ja, und diese Stimmung, die auch reinkommt. Und wenn man sich gestern auch noch angehört hat, was Mr. Trump gesagt hat, guess what, ob ich 200 oder 500% auf Zölle rauflege beim Auto, ich werde es einfach so hoch machen, dass aus Mexiko kein Fahrzeug mehr nach USA importiert wird. Ja. Das ist einfach ein Faktum, ne? Dem müssen wir uns in der Form natürlich auch stellen. Und gerade in der Automobilindustrie geht jetzt ein massiver Ruck durch, ne? Wenn man sich das ansieht. OEMs bauen Batteriefabriken in Mexiko, damit sie den amerikanischen Markt bedienen können, investieren und dann kommen solche Dinge rein. Man wird sehen, wie man damit umgehen kann, was kann ich wieder zurückziehen. Aber ich würde bei der Judith bleiben an der Stelle, wir dürfen den Kopf nicht in den Sand stecken. Wir haben in der Form extrem viel beigetragen zum Automobil und dass das Automobil das ist, was es heute ist. Ja. Und wir müssen uns dem auch besinnen, dieser Stärken und einfach das nutzen, was an Angebot da ist. Ich muss nicht alles selber erfinden, um es anwenden zu können. Am Ende des Tages zählt das Geschäftsmodell, was kann ich dem Kunden anbieten. Und da muss ich nicht alles erfinden, sondern integrieren. Und da kriege ich auch wieder die Geschwindigkeit, wenn ich nicht wieder alles selber entwickeln muss. Ja.
Vielen Dank. Ich möchte Sie bitten, das alles als Aufforderung zu sehen, diese einführenden Worte der Experten. Ich habe auch den Eindruck, dass wir hier mit Leuten zusammensitzen, die jetzt die Ärmel hochkrempeln müssen und die sich vernetzen müssen. Und deswegen bin ich sehr dankbar den Initiatoren von diesem Event, dass wir eben diese Plattform hier schaffen können. Ich möchte Sie alle einzeln persönlich aufrufen, hier jeden Kontakt zu nutzen. Das sind alles Leute wie Sie, die wirklich da in diesem Bereich auch einen Hebel haben und da etwas bewirken können. Ich möchte mal fast das Hype-Thema, was mir bis vor einer Weile als höchstes Thema nach einem anderen Thema, über das wir sicher noch sprechen werden, vorkam in den Konzernen. Es ist die künstliche Intelligenz. Und ich möchte mal hier fragen, wir haben hier sehr unterschiedliche Menschen da, die sehr unterschiedlich mit diesem Thema umgehen. Mich würde jetzt zunächst mal interessieren, welche Rolle spielt denn die künstliche Intelligenz aktuell in der Entwicklung von Automotive Software und wie gut laufen die Bestrebungen, die ja deutlich da sind, die auch zu implementieren? Sind wir da schon auf Max oder sind wir da noch so auf 1 von 10? Vielleicht, Stefan, darf ich dich zuerst mal fragen?
Ja, gern. Also ich glaube vielleicht einmal grundlegend, ich meine, AI oder das, was wir heute haben, das steckt ja noch in den Babyschuhen. Da wird noch wahnsinnig viel kommen. Wir stecken da wirklich in einer rapid kommenden Entwicklung, die sehr schnell gehen wird, wo wir eigentlich noch gar nicht absehen können, wohin das wirklich geht. Also das ist absolut am Kommen. Ja. Wenn wir natürlich jetzt speziell in den Automobilbereich hineinschauen oder zumindest dort, was für mich sichtbar ist, ja, dann zerfällt es ja dort in unterschiedlichste Anwendungsbereiche, die ich habe. Ja, da ist ein Bereich die ganze Entwicklungsseite, ja, Coding-Tools, ja, Requirements Management, ja, beispielsweise so Dinge auch, die relativ interessant sind. Ja. Wir sind ja zum Beispiel deswegen so langsam, weil wir riesige Pflichtenhefte noch haben, die dann irgendwie verarbeitet werden müssen, die getestet werden müssen. Auch dort kann ich mit AI wahnsinnig viel herausholen und das vielleicht einmal auch auf eine Essenz runterbringen, wo ich sage, ja okay, ich gehe jetzt wirklich dort hinein und konzentriere mich auf den funktionalen Kern, was möchte ich eigentlich wirklich vor Kunde zeigen und nicht noch einmal diese 1000 Seiten an Legacy da mitschleppen. Also jetzt nur als kleines Beispiel. Das heißt, das ganze Coding wurde schon angesprochen, ja, Coding beschleunigen, Testcases bauen zu beschleunigen, Requirements. Also das heißt, dort gibt es natürlich wahnsinnig viel Potenzial, das, glaube ich, jetzt Schritt für Schritt gehoben wird. Ja, dann gibt es natürlich das Thema Bilderkennung, Bildwahrnehmung, ja, das ganze Thema Automated Driving, da gibt es auch schon die Trends, dass man sagt End-to-End AI, praktisch, ich habe AI von der Sensorik bis zur Aktuatorik, da könnte ich dann zum Thema Safety noch was beitragen. Ist ein extrem großes Thema, extrem erfolgreich, ist heute gesetzt, ja, da gibt es wenig Alternativen dazu, ist ganz klar. Und dann gibt es natürlich auch das ganze Thema AI noch auf der User-Interface-Ebene. Wie mache ich das User-Interface smarter, ja, dass ich dem Fahrzeug sozusagen irgendwie komplexere Kommandos, Wünsche, Zusammenhänge mitgeben kann, die ich dann erledigt kriege über das Backend, über lokale Dinge, die ich im Fahrzeug tun kann.
In deinem Verantwortungsbereich bremst du eher den Einsatz aus Vorsicht oder gibst du Ziele raus, da mehr zu machen?
Nein, also ich stehe da voll am Gas, ja, bei dem Thema, ja, also ich pushe das voll, ja, weil wir das benötigen auf unterschiedlichsten Ebenen und speziell jetzt auch auf der Entwicklungsseite, die Entwicklung besser zu machen, schneller zu machen, auch Safety-Themen zu treiben, also Requirements Management, Test Cases, also all das.
Ja, jetzt frage ich mal Karin, du hast ja da in deinem Portfolio wunderbare Produkte auch dazu. Siehst du die Automotiveler munter anwenden oder sind sie zögerlich?
Ja, gute Frage. Also tatsächlich, ich habe es ja gerade schon erwähnt, wir sehen super viele gute Anwendungsfälle, auch gerade in der Automotive-Industrie. Ist natürlich auch für uns jetzt in meinem Bereich, sind es mit die größten Kunden für uns, mit denen wir intensiv zusammenarbeiten. Und da sehen wir schon ganz viele spannende Einsätze von AI. Geht mehr, ja, auf jeden Fall. Könnte schneller sein, ja, auf jeden Fall. Ich glaube, da sind wir natürlich als Deutsche manchmal etwas vielleicht zu zögerlich, erstmal alles abzuprüfen, statt zu sagen, Mensch, jetzt setze ich es doch schon mal in einem unkritischen Bereich einfach an und mache einfach selber Erfahrung und nicht jedes Häkchen sich vorher abzuholen, bevor man es überhaupt irgendwo einsetzt. Aber tatsächlich, wir sehen es über den ganzen Product Lifecycle, wie du sagst, in meinem Bereich jetzt speziell GitHub Copilot in der Entwicklung ist natürlich ein großes Thema, sehen wir schon häufig im Einsatz mit sehr gutem Feedback, auch in der Automobilbranche. Auch da muss man gucken, wofür, mit welcher Zielsetzung will ich es einsetzen, aber ich glaube, wenn man es für die richtigen Themen einsetzt, eben gerade repetitive Tasks, Testcases generieren, kann man wirklich super schnell auch Zeit einsparen und Effizienz und auch Entwicklerzufriedenheit erhöhen, was wir ja vorher schon gehört haben. Entwickler als knappe Ressource, ja auch ein wichtiges Thema. Wir sehen es aber wirklich im gesamten Product Lifecycle, also wir sehen es im Requirements Engineering, ich glaube, die Inga wird nachher noch auch ein paar Fälle vorstellen. Wir sehen es tatsächlich in der Entwicklung von Fahrzeugen mit den Themen, die gerade schon genannt wurden, auch Augmented Reality, dass da auch AI zum Einsatz kommt, verstärkt, dass man einfach ein einfaches User-Interface hat, um Fragen zu stellen. Wir sehen es aber auch im Customer Service natürlich im Einsatz und da kann man, glaube ich, auch, was uns ja viel bewegt, sowohl Innovation vorantreiben, als auch auf Effizienz und Kosteneinsparungen gehen und da sehen wir es auf jeden Fall. Also von dem her, es gibt noch Luft nach oben, wo wir auch gerne zusammenarbeiten, aber wir sehen schon viele spannende Beispiele.
Okay, ich frage mal Wolfgang, musst du die Leute eher drücken dazu oder musst du sie bremsen? Wie empfindest du die Anwendung von KI?
Also wenn ich jetzt mal bei uns reinschaue, dann glaube ich, drücken überhaupt nicht. Ja. Im Gegenteil, Ingenieure sind in der Form immer begeistert von neuer Technologie und die anzuwenden und in der Form einfach zum nächsten Level zu bringen. Was für mich spannend war jetzt auch mit der KI, ich erinnere mich zurück, als etwas jüngerer Ingenieur hatten wir die ersten neuronalen Netze in Motorsteuer- und Getriebesteuergeräten drinnen. Ja? Also KI unter Anführungszeichen. Woran es gescheitert ist, war einfach, ich sage, die Rechenleistungen war heute noch nicht gegeben. Ja? Ansonsten hätte man dort schon deutlich mehr können machen. Und wir sehen jetzt kommt die High-Performance Computing, jetzt haben wir die Hardware-Plattform, wo wir die Dinge auch machen können und die in der Form auch passieren. Und für mich führt gar kein anderer Weg vorbei, wenn man sich heute so ein Software-Defined Vehicle ansieht und wenn man das heute hört über das Deployment, Continuous und so weiter mit der gesamten Anzahl von Daten, ja, wird ein Mensch in der Form nicht mehr zur Rande kommen. Das heißt, ich brauche heute in der Form die KI, um Mustererkennung zu machen, um Dinge zu erkennen, wo ich sage, wo habe ich Anomalien, wo schiebe ich weg. Jost Bernhard hat über den Data Lake gesprochen, wie sortiere ich den, was leite ich wieder ein in mein System, ja, um unter Anführungszeichen den nächsten Loop auch zu machen. Für mich ist das etwas, die Ingenieure nehmen das, ich würde es nicht sagen wie eine Droge, ja, aber es ist unglaublich, was daraus entsteht und auch wieder an Ideen und Innovationen im Prozess, aber auch in den Produkten. Ne? Und wenn wir es nicht machen, es macht jemand anders. Also noch einmal, verhindern ist, glaube ich, die falsche Strategie. Ja?
Ich verstehe, also ich höre bei euch zwischen den Zahlen bei allen dreien auch raus, dass ein deutscher Konzern nicht unbedingt zu dem schnellsten Institut gehört, was es auf der Welt gibt und dass wir da uns oder die OEMs, Tier 1s und Supplier sich selber oft die Schnelligkeit verbauen auch. Zumindest die Schnelligkeit, wenn nicht gerade sogar die super versalzen. Du darfst dich sicher nicht sehr konkret dazu äußern, aber...
Ja, aber es gibt zum Beispiel, wenn wir heute, schauen wir uns in Deutschland mal OEMs an und dann gibt es ja dort, ich sage auch Arbeitnehmervertreter, ne? Da gab es Diskussionen, wie kann ich KI verhindern und wir machen eine Betriebsvereinbarung zum Thema KI, ja? Wo ich einfach sage, ich weiß nicht, wo sind wir jetzt hier gelandet an der Stelle? Ja? Also in der Form, ich versuche es eher einzubremsen und wegzuschieben. Und das ist das Thema Verhindern. Ja, ich kann das Thema nicht verhindern. Das findet statt. Ohne uns und mit uns, ja, oder um uns herum. Ja. Und ich glaube auch dieser Kulturwandel, der absolut notwendig ist. Ja, ich kann nicht beharren. Ja, ich muss, unter Anführungszeichen, für mich, ich sage es immer auf diese Slackline, die ist jetzt mal. Ja. Jetzt ist in der Form nicht ein gutes Fundament, ein breiter Boden, der bewegt sich nicht, jetzt ist mal Slackline angesagt. Ja. Und da muss man drauf gehen. Ja? Ansonsten wird man nicht dorthin kommen, wo wir hin möchten und wo wir auch hin müssen, ja, als Industrie.
Wenn ich jetzt mal Stefan dich frage, ich würde dich mal als Digital Native bezeichnen und relativ schnell, wo Riesenkonzerne sehr viel langsamer sind. Ist das euer Riesenvorteil, dass ihr Dinge schnell adaptieren könnt? Vielleicht ist das nicht so, aber...
Also es ist sicher für uns ein Vorteil, dass wir sozusagen als Softwarefirma geboren worden sind. Ja. Also wir haben als Softwarefirma gestartet. Ja. Ich unterrichte noch immer an der TU Informatik. Ja. Also ich sehe mich da schon als Digital Native. Ja. Ja. Und deswegen haben wir da eine total andere Genese. Und vielleicht, was auch absolut interessant ist, wir haben ja jetzt in der Automobilindustrie diese Transition zum Software-Defined Fahrzeug. Ja. Das heißt, bisher war es ja so, ich hatte irgendwo, die Elektronik war ja sozusagen ein notwendiges Beiprodukt zu einer Funktion. Also eine Klimaanlage hat eine Elektronik gehabt, ein Motor hat eine Elektronik gehabt, der Sitz hat eine Elektronik, die Türe hat eine für den Rückspiegel und so weiter. Und jetzt beginnt sich das auf einmal zu drehen, dass es Softwareplattformen gibt und dass die Softwareplattformen und die Elektronikplattformen im Zentrum stehen und dass man Autos rund um Elektronikplattformen zu bauen beginnt und dass die Entwicklungszyklen sich entkoppeln. Ja. Und dann kann man natürlich hineinschauen, wo gibt es Industrien, was tut sich auf der Welt sonst. Ja. Und da kann ich auf der einen Seite schauen, ich kann in den Cloud-Bereich hineinschauen, ja, dort habe ich praktisch eine komplett stark parallelisierte Entwicklung. Ich habe praktisch mehr oder minder unbeschränkte Ressourcen. Ich kann im Minutentakt Software deployen. Ich kann aussuchen, ich möchte jetzt die Software an eine Usergruppe von so und so vielen Usern einmal partiell ausrollen und wenn man merkt, da ist das Feedback schlecht oder gut, kann ich dann sagen, ja okay, ist gut oder ist schlecht und ich mache da iterativ weiter und ich kann praktisch durch diesen Trial-and-Error-Prozess, durch Messungen kann ich das in einem extrem hohen Tempo vorwärts bewegen. Ja. Dann haben wir eine andere Industrie, die auch extrem erfolgreich ist, das ist der Halbleiterbereich, wenn man dort in die SoCs hineinschaut, also High-Level-SoCs, die ja die ganze Infrastruktur treiben und sozusagen diese Softwarebeschleunigung, die wir haben, überhaupt erst möglich machen. Das heißt, dort bauen wir jetzt am Milliarden-Transistor-Device und das muss aber First Time Right sein. Das heißt, ich habe dort einen komplett anderen Entwicklungsprozess, weil die Einmalkosten so extrem hoch sind für so ein Device, die Maskenkosten und die ganzen Setup-Kosten, da rede ich über hunderte Millionen, ja, und da kann ich nicht sagen, ja, wenn der eine Chip nicht funktioniert hat, dann schieße ich da im Takt neu raus. Das geht sich nicht aus, zeitlich nicht, kostenmäßig nicht. Ja. Das heißt, die haben einen anderen Prozess gemacht, die machen die ganzen Architekturen und die Systeme so resilient, dass sie mit Errata-Sheets und ein paar Bugfixes und Firmware-Patches das dann doch irgendwie noch hinbekommen, aber sie haben natürlich auch einen sehr stark automatisierten Design-Prozess, der dieses Correct by Design in den Vordergrund stellt, ja, das wir auf der Softwareseite viel weniger haben. Ja. Und wir stehen ja eigentlich mit dem Thema, weil wir hauptsächlich sicherheitsgerichtete Software machen, wir stehen irgendwo in der Mitte. Ja. Und wir versuchen praktisch von beiden Seiten irgendwie zu lernen, dass wir uns da gut hineinkalibrieren können auf dieses Thema. Und ich glaube, das trifft eigentlich auf breiter die Automobilindustrie zu.
Darf ich da Wolfgang mal fragen, ist Geschwindigkeit ein Riesenthema in deinen Projekten mit den Autoherstellern?
Definitiv. Ne? Also Geschwindigkeit ist eines. Also jeden Tag hört man irgendwo dieses Thema Chinese Speed. Ja? Und wenn man dann nachfragt, kann es nur keiner so richtig erklären. Ja? Ja. Und ich habe dann aber gesagt, um ein Ziel zu erreichen, brauche ich Geschwindigkeit und Richtung. Ne? Wenn ich nur eines von den beiden habe, werde ich das Ziel nicht erreichen. Und wir haben heute schon ein bisschen was über Kultur und Adaptieren von Organisationen und Systemen gesehen. Ne? Und wenn man sich heute das mal anschaut zu dem Thema Chinese Speed, und das ist nur meine These an der Stelle, man ist deutlich risikofreudiger, ja, wenn man hier in Dinge auch reingeht, definitiv. Und das Zweite ist, wir haben heute schon viel gehört über Requirements Management. Wenn wir heute hier unser Systems Engineering oder Model-Based Systems Engineering, alle Anforderungen müssen am Anfang fertig sein, dann legen wir los. Ja. Muss ich sagen, ist für mich absolut etwas, was wir vom Tisch wischen müssen. Wenn wir heute sehen, wie die Softwareentwicklung stattfindet, dann lege ich heute los. Wenn ich heute diese kurzen Zyklen habe und meine Funktionalität weitestgehend über das Thema Software entsteht, ja, dann muss ich vorher nicht in der Form Monate und vielleicht ein Jahr warten, bis alles in den Requirements drinnen steht. Ja. Das kann ich später. Das ermöglicht mir jetzt diese Technologie. Und Geschwindigkeit ist alles. Und das haben wir gerade in den letzten 5 Jahren auch in China gelernt. Ja. Ob die Geschwindigkeit übersetzbar ist hier für uns, ja, würde ich schon einmal in Frage stellen, weil es ist eine andere Kultur und es ist eine andere Regierungsform, ja, machen wir uns nichts vor. Aber trotzdem kann man ein Stück weit daraus lernen. Und ich glaube, wir werden uns in der Kultur, wie wir entwickeln, dass wir wieder risikoaffiner werden. Ja. Und das heißt nicht die Augen zumachen und die Ohren zuhalten, sondern wenn ich die Risiken kenne, dann kann ich sie im Prozess auch in der Form sauber betrachten und kann jedes Mal sagen, okay, hier, stopp. Ja. Aber nur so werden wir wieder zu einer Geschwindigkeit zurückfinden, ja, die uns wettbewerbsfähig macht. Ja, definitiv. Und wir sollten nicht glauben, dass es nur KI braucht, um die Geschwindigkeit zu bekommen.
Ja. Also ich würde da gern kurz einhaken, weil wir haben an mehrere, also wir haben die Möglichkeit gehabt, in mehreren chinesischen Programmen auch teilzunehmen, wo wir wirklich dann in 2 Jahren in Serie gegangen sind mit Fahrzeugen. Und der Unterschied ist wirklich total frappant, ja, und ich kann das nur voll bestätigen. Also es ist zum einen einmal ist es so, dort würde niemand auf die Idee kommen, jetzt sage ich mal irgendwo ein Querschnittslastenheft, ja, und da gibt es dies und jenes, sondern die machen das super pragmatisch. Ganz schnelle Entscheidungen, dass sie sagen, ja, okay, welche Funktionalität wollen sie haben, wer bietet ihnen die Funktionalität, sage ich mal, zu 80% an und den nehmen wir. Und da wird dann nicht geschaut, ja, erfüllt er da alle Corner Cases und ist es compliant zur Konzernrichtlinie und sonst was. Das heißt, die Entscheidungswege sind viel schneller, es ist einfach viel pragmatischer auf die Funktionalität und auf das Ziel hin orientiert, was will ich eigentlich erreichen. Und natürlich ist es auch eine Bereitschaft, das ist natürlich kulturell auch ein Thema, zu sagen, ja okay, ich bin auch bereit, mich mit einem geringeren Qualitätslevel zufriedenzustellen, aber ich kann ja dann noch einmal ein paar Updates nachschießen, wo das geht. Ja. Und es ist einfach so, die haben dort eine hyperkompetitive Situation, weil es viel zu viele OEMs gibt, die jetzt der Reihe nach auch wahrscheinlich aussterben werden, einige. Aber das heißt, jeder hat dort einen Druck, in kurzer Zeit was zu bringen. Und jetzt, wenn da jemand kommt und sagt, es würde in 4 Jahre dauern, bis er dann ein Fahrzeug auf die Straße bringt, da ist er schon tot, weil da ist er nicht mehr wettbewerbsfähig.
Ja.
Karin, kann ich mal fragen, dieses Software-Defined Vehicle ist teilweise Realität, aber teilweise auch ein Stern, an dem man sich gerade ausrichtet. Wie erlebst du das? Siehst du die Automotive-Hersteller schon auf einem guten Weg, die Software so in den Mittelpunkt zu stellen? Mir persönlich geht es so, dass ich oft den Eindruck habe, dass man da in der Hardware-Welt verfahren ist und noch nicht wirklich Software-Defined sein Vehicle sozusagen
ja,
denkt.
ich glaube, auch da, ich meine, erzählt viel von den Punkten, was gesagt wurde. Und ich glaube, wir haben heute schon viele Gespräche geführt, gestern Abend auch. Ich glaube, wir sind da auf gutem Weg wieder. Es gibt ja auch hier viele Software-born-Firmen, die dann wieder zuliefern oder integriert werden. Deshalb ist es auf gutem Wege, würde ich sagen. Dennoch auch da, ich glaube, müssen wir Geschwindigkeit zulegen, wie ihr es beschrieben habt. Und ich denke, viel von dem, was wir eben sehen, ist tatsächlich, wir kommen aus einer langen Historie von Hardwareentwicklung im Automotive-Bereich. Und das ist eine andere Kultur, das sind andere Entwicklungsprozesse. Und ich glaube, da sich wirklich darauf einzulassen und auch zu lernen von dem, was Softwareentwicklung anders macht, wäre da auch mein Aufruf. Und einfach eben, wie es gerade auch Stefan beschrieben hat, vielleicht nicht zu sagen, okay, jetzt mache ich mein Querschnittslastenheft erstmal, lege erstmal los, wenn alles ganz perfekt ist und 100% erfüllt, sondern zu sagen, okay, was ist jetzt für dieses Requirement oder diese Funktion das Richtige, weil die brauche ich jetzt schnell und dann einfach loszulegen an mancher Stelle, ohne natürlich Sicherheit außer Acht zu lassen oder eben die grundlegenden Compliance- und Security-Themen. Aber einfach an mancher Stelle da agiler zu werden und von dem zu lernen, was Softwareentwicklung ausmacht, wie du auch beschrieben hast. Ich meine, letztendlich auch von anderen Branchen vielleicht mal zu lernen und sagen, ich nehme da die Best Practices raus und bringe die ein, weil am Ende ich glaube, sehen wir alle, dass Software den Unterschied machen wird für Autos in Zukunft und nicht mehr unbedingt die Hardware. Und ich glaube, das muss ich dann auch als meinen USP sehen und den auch leben und den eben auch im Unternehmen entsprechend kulturell ins Zentrum stellen und mich kulturell darauf einlassen, weil auch da am Ende ist es Culture, Process, Tools und ich muss mit der Kultur anfangen. Und ich glaube, da zu lernen, vielleicht von dem, was Softwareentwicklung ausmacht, sollten wir auf jeden Fall.
Da haben einige, Leute, die ich hier getroffen habe, ihre eigene Einstellung zu der Kultur. Das finde ich, also für mich persönlich war es immens erhellend, dass in den meisten Fällen man seine eigene Kultur richtig einschätzt, nicht zufrieden ist, aber nicht wirklich darüber hinauskommt, weil wir als Ameisen in einem Staat arbeiten, in einem Konzern, gerade im Automotive-Bereich, wo es sehr wichtig ist, dass alle zusammenarbeiten, dass jedes Zahnrad ineinander geht. Und da würde ich mal in den Raum, bitte melden Sie sich und sagen was dazu, kann jemand seine Version erzählen von Skalierbarkeit, den Möglichkeiten von Skalierbarkeit und Chinese Speed, die wir erreichen wollen. Ist vielleicht jemand schon aufgewärmt genug? Kann dazu was sagen? Ah ja. Bitte stellen Sie sich kurz vor.
Ja, danke. Mein Name ist Jürgen Kaiser. Ich bin der CEO und Gründer von 3Motion. Wir waren 3,5 Jahre in China, haben dort ein Fahrzeug mitentwickelt, komplett modellbasiert. War in Deutschland nicht möglich und das ist der Unterschied zwischen Deutschland und China, dass man dort die Möglichkeit kriegt, neue Dinge zu tun, die hier nicht möglich wären. Deswegen sind wir nach China. Ich möchte eine Lanze brechen für das deutsche Engineering. Hier sind viele, die dafür stehen. Dieses chinesische Modell, dieser Erfolg wäre nie möglich gewesen ohne uns. Wir haben den Chinesen beigebracht, wie man das macht. Die haben es umgesetzt, was wir, der Jost weiß es sehr genau, wir haben zusammengearbeitet, was wir in Deutschland, in Europa nicht hingekriegt haben. Das ist das eine. Das zweite wäre eine Frage an Microsoft. Microsoft, also wir sind Toolhersteller, wir entwickeln modellbasierte Engineering-Systeme und der einzige wirklich wichtige Mitbewerber am Markt für uns ist Microsoft, weil alle Ingenieure mit Excel arbeiten, mit Visio, mit PowerPoint, ja, und Requirements in Word schreiben. Und jedes Mal, wenn man merkt, dass die bestehenden Tools, UML, Prevision, zu komplex und zu teuer sind, um in der Zeit wie die Chinesen ein Auto zu bauen, macht man es wieder wie die Chinesen in Excel. Und meine Frage wäre, warum entwickelt Microsoft dann nicht ein Werkzeug wie unseres, was diese Engineering-Welt abdeckt, ja, und Hardware-Co-Design, Hardware-Software-Co-Design auf einem modernen Desktop-PC oder Notebook ermöglicht. Warum?
Ich glaube, am Ende ist es tatsächlich, ich würde sagen, Adoption of Innovation und Adoption of Tools. Ja. Wir sehen das jetzt nicht nur bei Excel, was auch bei uns im Unternehmen noch gern genutzt wird, obwohl wir, glaube ich, auch innovativere Tools inzwischen haben. Ich sehe das Gleiche mit GitHub Copilot, mit AI. Es ist die klassische Adoption of Innovation. Und ich glaube, Microsoft, also Excel ist ein wunderbares Produkt. Ich liebe es persönlich auch sehr, ja, auch mit Power BI noch sehr user-friendly. Pushen wir das jetzt, glaube ich, für Requirements Engineering oder für Product Lifecycle Management? Nein, haben wir da Partner, mit denen wir partnern, um Lösungen gemeinsam auf den Markt zu bringen? Auf jeden Fall. Stecken wir vielleicht in jedem Unternehmen, bei jeder Person, die da arbeitet, die gern Excel nutzt? Nein, von dem her würde ich sagen, lassen Sie uns gemeinsam dran arbeiten, um da vielleicht die richtigen Tools an der richtigen Stelle zu positionieren und schnell in die Nutzung zu bringen.
Ja, dass Ingenieure methodisch manchmal wirklich etwas besonders sind, musste ich auch sehr lernen, aber Excel, hier bitte mal, stellen Sie sich kurz vor.
Hallo, Henry Bastian von der Carriot. Auf die Frage hin, was bedeutet Chinese Speed, habe ich halt eine ganz persönliche Erfahrung, die ich mal gerne mit euch teilen möchte. 2004 habe ich mein Studium der Informatik aufgenommen und es stand vorne ein Professor, der über Kommunikationstechnologien sprach und sagte, heutzutage sind wir in der Lage, ein vorausfahrendes Fahrzeug zu detektieren, 2004 war das, ein vorausfahrendes Fahrzeug zu detektieren und eine Notfallbremsung zu erkennen und selber einen Auffahrunfallschutz zu implementieren, sodass das hinterfahrende Fahrzeug nicht auf das vordere Fahrzeug auffährt. Das können wir heutzutage leisten, rein technologisch. Gehen wir aber zu den Kollegen von den OEMs, dann sagen die uns, um Gottes Willen, ihr dürft doch nicht automatisch bremsen. Ihr könnt eine Lampe angehen lassen und es darf Pling machen. Jahre später, Studium ist abgeschlossen, ich arbeite in einer Firma, die sich mit der V2X-Technologie auseinandersetzt und mit der Implementierung oder also On-Scale-Integration in die Fahrzeuge. Das Unternehmen wurde 2016 dann gegründet. Vorher hatte mein Chef, CEO, der hatte halt vorher da schon in einem anderen Unternehmen versucht, der Investor war nicht besonders interessiert daran, Automotive Business voranzutreiben. Also kam ein chinesischer Investor nach Deutschland und hat das Startup hier unterstützt in Berlin. Fand das Portfolio mit V2X-Technologie-Integration in die Fahrzeuge mega spannend. Die V2X-Technologie, ich weiß gar nicht, wie sie jetzt zurzeit in Europa dasteht, in Deutschland und in welche Fahrzeuge sie tatsächlich integriert ist. Ich weiß es auch ehrlich gesagt gerade nicht mehr, ob es BYD tatsächlich drin hat. Aber folgender Punkt. 2016 das Unternehmen gegründet, 2018 kam dann der Bescheid von der Kommunistischen Partei in China, dass sie gesagt haben, sie wollen mit 2020 diese V2X-Technologie basierend auf Zellulartechnologie mit dem Hersteller Huawei in die Fahrzeuge integrieren innerhalb von 2 Jahren. Und ich habe die Technologie und die Use-Case-Diskussion schon im Jahr 2004 in Europa mitbekommen. Und bei den Chinesen war es politisches Programm, das in 2 Jahren einzusetzen. Das hat natürlich andere Kosten, also die Kosten gehen nicht auf die Entwicklungszeit, sondern haben dann andere Diskussionen. Ne? Es gibt dann, also die Diskussion, die dann geführt ist, wer trägt dann die Kosten? Und letztendlich waren sie halt vom Staat getragen, zu sagen, okay, wir gehen alle Risiken ein, wir gehen voll in, aber wir wollen das haben. Und das ist der Unterschied. Und wir wägen halt Risiken und Kosten noch ab und machen Wirtschaftlichkeitsanalysen, die an anderer Stelle nicht gemacht werden. Ja. Mit gewissen Risiken. Also wir verbergen die Risiken, wenn wir sagen, wir müssen einfach nur schneller werden.
Ist sowas reproduzierbar?
Ja, nee, absolut fair. Ja. Aber das ist einfach ein Setting, das ist gegeben. Ja. Ich kann das sage ich mal, diesen 5-Jahresplan in China kann ich nicht vom Tisch schieben. Ja. Es gab auch einen OEM hier in Deutschland, der gesagt hat, oder dem Berater gesagt haben, also das mit den E-Fahrzeugen in China, das brauchst du nicht für deine CO2-Erfüllung, nicht in dem Volumen. Leider hat der Berater nicht den 5-Jahresplan gelesen. Ne? Und deswegen steht der OEM jetzt auch dort, wo er jetzt auch steht. Ja? Aber das ist einfach ein Setting. So, und das ist eine Gegebenheit, der sehen wir uns gegenüber. Ja? Jetzt kann ich wegschauen, ja? Oder ich kann das nochmal anschauen und sagen, okay, aber das ist mein Wettbewerber oder das wird zukünftig mein Wettbewerber auch sein, der hat die Rahmenbedingungen. Wie kann ich unter Anführungszeichen hier vorgehen? Ja? Und der OEM jetzt partnert mit einer chinesischen Plattform. Ja? Und nachdem das dort anscheinend sehr gut funktioniert, hat er sich auch entschieden, in den USA zu partnern mit einer Plattform, ja, weil es einfach schneller ist. Ja. Wir werden sehen, ob das die richtige Antwort ist an der Stelle. Ja. Aber zumindest wird es jetzt ausprobiert, weil es gibt sonst keinen anderen Weg. Ja. Und das ist das, wo ich sage, da müssen wir halt einfach jetzt auch schneller und klar entscheiden. Ja. Klar ist ein Risiko dahinter, aber gibt es eine andere Alternative?
Vielen Dank. Da kurz vorstellen.
Danke. Ich nehme das mal gerade auf, aber mit einer Frage, und zwar China Speed, EU-Regularien langsam. Wie gehen wir denn mit dem EU-AI-Act um? Was bedeutet das jetzt genau für uns? Also hält uns das auf, macht uns das teuer oder sollten wir uns da schnell einmischen, bevor es gesetzt wird?
Wow, vielen Dank. Das fände ich toll. Hier sitzt ein Riesenplenum. Will jemand auf der Bühne etwas sagen? Ich würde Sie gleich sowieso in Beschlag nehmen zu diesem Thema.
Also es macht uns auf keinen Fall schneller. Definitiv an der Stelle. Und das ist für mich so wieder das Erste, da kommt was Neues und wir beschäftigen uns damit, wie ich unter Anführungszeichen das sofort wieder abgrenze, ohne dass ich mir im Klaren bin, welche Potenziale, welche Hebel habe ich wirklich. Ja? Wir haben sofort die Risiken diskutiert, wir haben nicht die Chancen diskutiert. Ja? Und also ich sehe es zumindest schon, dass die Industrie, wenn das ein Hebel für die Industrie ist, und das ist ein Hebel, ja, dann muss man sich an der Stelle nochmal ganz klar aufstellen. Ja? Also es gibt Lobbying in Brüssel, ja, von jeglicher Industriesparte. Ja? Ob das jetzt ein Automobil ist, wie auch immer. Ja? Und ich glaube, vielleicht ist es nur noch nicht ganz verstanden worden, aber es ist ein Riesenhebel. Und natürlich müssen wir meines Erachtens nach in Brüssel dort als Industrie und die Industrievertreter auch mal klar Stellung beziehen. So, keine Frage. Ja.
Ja, und ich glaube auch, also ergänzend vielleicht, also ich würde auch sagen, einmischen, ja, auf jeden Fall, weil es ist eine Riesenchance, die wir nicht verpassen können, wollen und dürfen. Und ich glaube, das in die richtige Richtung zu bewegen, auf jeden Fall. Und auf jeden Fall Responsible AI ist ein Thema, ja. Also deshalb, ich glaube schon, man muss da die richtigen Regularien vielleicht setzen. Aber ich glaube, wir können uns auch nicht leisten, jetzt zu sagen, so, jetzt warten wir mal 2 Jahre, machen mal gar nichts. Und dann gucken wir mal, was entschieden wurde, sondern in dem Rahmen weiter agieren und proaktiv weiter agieren, der da ist. Und ich glaube, da gibt es viel Spielraum aktuell und es kann viel gemacht werden. Weil wenn wir da, ich glaube, den Anschluss verlieren, dann haben wir vielleicht, ob es nun China ist oder ob es andere Länder sind, noch.
Aber ich kann mal, in Ihrem Haus zum Beispiel, dann werden Sie sich eben entscheiden, bestimmte KI-Themen nicht in Europa zu machen. Dann gehen Sie, haben Standorte in China, Sie haben Standorte in den USA, Sie haben Standorte in Indien, dann werden Sie dorthin gehen. Ja, definitiv, weil Sie werden sich dieses Business werden Sie sich nicht vom Teller ziehen lassen, da bin ich mir ganz sicher. Sie machen es halt nur nicht hier in Deutschland. Ja? Mit allen Konsequenzen für den Standort.
Ich darf mal Herrn Wollschläger vielleicht fragen? Ich dachte, wir hätten körpersprachlich uns darauf geeinigt.
Hallo, Dirk Wollschläger, ex-IBM Global Automotive Leader, jetzt beim K-Institut. Ich glaube, wir haben hier ein Kernthema schon, ist ja schon herausgekommen. Ich will noch kein Bashing machen, aber das ist einfach, wir haben einfach ein riesiges Kulturproblem, vor allem in der deutschen Autoindustrie bei den OEMs. Ja, ich meine hier, du arbeitest ja bei einer Tochtergesellschaft eines OEMs, aber ich will jetzt auch kein Bashing machen, aber nur mal ein Beispiel, das ich persönlich erlebt habe. Wir haben als IBM 2016 auf der CeBIT, die es damals noch gab, ein High-Performance-Computing-Device mal entwickelt, zusammen mit unseren Forschern in Zürich, immerhin ein Forschungslabor, das mehrere Nobelpreisträger hervorgebracht hat. Das ganze Ding war wassergekühlt, war die Idee des High-Performance-Compute, wir haben das In-Vehicle Cloud genannt. Ja, wir haben das vorgestellt. Ich war in Brüssel bei so einem Hearing, haben wir das vorgestellt, saß zufällig Stefan Grote neben mir vom BMW, kennen viele hier. Wir haben das danach dann diskutiert mit einigen und dann war ich bei OEMs und dann haben wir es vorgestellt und dann habe ich in ganz ernste Gesichter geguckt immer und dann haben die gesagt, Herr Wollschläger, Sie verstehen das Auto nicht. Und das ist so, da habe ich so mitgenommen, ich weiß noch, es war 2016, ich erinnere mich daran, weil kurz vorher die schreckliche Attentate in Brüssel war, deswegen musste ich da durch lange Schlangen im Flugplatz. Aber das ist seit heute, bis heute hat sich das nicht geändert. Alles, was not invented here ist, bei den OEMs, da können Sie noch so viele nehmen. Heute Morgen ist Jan Becker genannt worden, ne, von dir, Jos. Jan hat eine super Lösung, die wir, mein Ex-Kollege sitzt hier von mir, von IBM, mit klassischer Middleware in der Computertechnologie schon lange haben, aber kein OEM nimmt es an. Wäre eigentlich Logik und wäre sehr vereinfachend für die ganze Entwicklung. Ja. Also das ist das Hauptproblem, die Kultur aus meiner Sicht.
Ich glaube, ich würde Ihnen vollkommen recht geben. Ein zweiter Aspekt ist vielleicht auch noch einmal das Geschäftsmodell, das man damals oder zum Teil heute auch noch hat. Ne? In der Form einfach produzieren und verkaufen. Ne? Mit dem Software-Defined Vehicle kommen wir natürlich in ganz andere Möglichkeiten des Geschäftsmodells. Ne? Warum wollen denn die OEMs dann ihren Eigenanteil an Software dramatisch erhöhen, ne? Von 10 auf 50, 60%, weil sie wissen, dass sie das in der Form benötigen, um dann bestimmte Geschäftsmodelle über den Lebenszyklus an der Stelle auch wirklich ziehen zu können, nämlich als OEM-Hersteller. Ja? Und das war damals überhaupt nicht bekannt, weil das Geschäftsmodell war entwickeln, produzieren, verkaufen und dann noch in der Form servicieren. Happy Camper, ja, hat alles gepasst in den Business Cases, saubere Erträge, so. Und das Geschäftsmodell ist ein anderes, ja, definitiv. Und das war zum damaligen Zeitpunkt, warum großartig etwas ändern, was super Erträge abwirft. Ja? Okay. Und ein Hochmut, muss man ganz klar sagen. Und wir sind ja wieder mal in unserem Hochmut an der Nase, sage ich einmal jetzt am Nürburgring, ja. Xiaomi SU7, ja, 4-türiges E-Fahrzeug, schnellste Nürburgring-Runde. Ja. Und ich glaube, dass viele OEMs hier in Deutschland nicht so schnell ein Mobiltelefon entwickeln können, wie die Xiaomi-Leute in der Form den SU7 entwickelt haben. Ja, und uns dort in der Form nochmal vorgeführt haben, ja, wie schnell so ein E-Fahrzeug sein kann, ja, und wie kompetitiv, ja, an der Stelle. Ja.
Oh.
Ja, aber jetzt, wie gesagt, können wir den Kopf in den Sand stecken und sagen, okay, vergessen wir, wir schieben alles aus Deutschland raus und wir machen nur mal noch Tourismus. Ja, haben wir ja auch schöne Flecken, wird aber nicht funktionieren. Ja. Und ich glaube, es werden dann auch die Talente nicht in dem Land bleiben. Ja. Die werden dann sagen, also wenn die Musik hier in den USA spielt, dann gehe ich nach USA. Ja. Highly welcome, Green Card, überhaupt kein Thema. Oder auch Indien. Wenn Sie Indien schauen, Bangalore zum Beispiel, bauen Sie gerade ein Silicon Valley auf. Ja. Die Headhunter, die hier in Deutschland und Europa rumlaufen, suchen Leute mit Automotive-Kompetenz für Bangalore. Da wird das zweite Silicon Valley aufgebaut in Indien. Ja. Und den schlafenden Riesen, den haben wir überhaupt noch nicht auf der Uhr hier in Europa. Ja. Und das kommt als nächstes.
Okay, hier ist noch ein
Beitrag
Beitrag von Stefan.
Ganz kurz, ich wollte noch was zum Thema Geschäftsmodell sagen, weil ich das einen total relevanten Punkt finde. Und das Geschäftsmodell ist natürlich super zentral, weil wenn ich jetzt Richtung Software-Defined Vehicle gehe und in dieses Thema hinein, dass ich Elektronikplattformen, High-Performance Compute habe, dann muss ich die Lifecycle-Kosten betrachten. Und ich muss betrachten, die Kosten, wie schnell bin ich, was auf den Markt zu bringen. Und wir haben heute teilweise bei den OEMs ja noch diesen Mindset, dass dann irgendwo, da wird das kleinere Memory eingebaut und ein bisschen eine kleinere CPU und dann gibt es noch 4 Abstufungen, weil da habe ich die Hardwarekosten dann nochmal super optimiert. Aber dass ich dann eine Integrationskomplexität habe, dass ich 4 Varianten managen muss, dass ich dann irgendwie ein Jahr spät beim SOB bin, weil ich die 4 Varianten mit Optimierungsmaßnahmen habe betreuen müssen, dass ich das überhaupt hineinkriege mit dem Schuhlöffel, die Software noch. Also diese ganzen Aspekte, die kosten ja gigantisch viel Geld. Und das heißt, selbst wenn ich jetzt gar nicht noch einmal ein neues Service-Oriented Business Model berechne, wo ich sage, ja, ich werde dem Kunden da super viel Geld noch einmal herausholen für die Leistung, aber nur die Tatsache, wenn ich eine vernünftige Architektur mache, wenn ich die stärker streamline, wenn ich weniger Varianten mache, sozusagen dieses Mindset-Denken, ja, ich verbaue nicht Schrauben, ich verbaue nicht mechanische Teile, wo es super ist, wenn ich eine billigere Schraube oder weniger Schrauben verbaut habe, sondern da sind extreme Folgekosten drinnen. Ja? Wie schnell kann ich mein Auto updaten? Wie schnell kann ich eine innovative Funktion bringen? Also diese Dinge, da ist, glaube ich, auch noch ein Kulturwandel notwendig. Und mein letztes Statement dazu, da gibt es von einem Österreicher namens Peter Drucker, der in der Managementlehre ja bekannt ist, gibt es das Statement, Culture eats strategy for breakfast.
Ja. Ja. Vielleicht eine kurze Anmerkung noch für diejenigen unter Ihnen, unter euch, die das nächste Mal wieder in China sind. Geht mal rein, bei Xiaomi zum Beispiel, in so einen Mobiltelefonladen, da stehen dann auch meistens die Autos. Ja, und dann sieht man auf dem Specsheet, wie viel Teraflops der HPC hat. Ja? Versuchen wir es mal hier reinzugehen. Und das ist das, so erziehen die den Kunden. Der Kunde sagt, okay, wie performant ist mein HPC, weil dann kriege ich ja, und das ist eine Kaufentscheidung. Ja, und das ist genau das. Und das, dann sind wir, wenn Sie ein deutsches Produkt am chinesischen Markt anschauen, dann fällt das dramatisch ab in seiner HPC-Performance. Ja. Aber das ist eine klare Kaufentscheidung, so wie beim Handy heute, wo ich sage, wie viel Speicher oder welchen Prozessor habe ich drinnen. Ja. Und das sind Dinge, die realisieren wir gar nicht. Ja. Das muss man sich einfach mal dort vor Ort anschauen. Klar.
Ja, was wieder der Punkt ist, dass Software am Ende der USP ist und darüber die Kaufentscheidung getrieben wird. Und ich glaube, das und auch die Qualität, weil wenn man technische Schuld von Anfang an aufbaut, dann sind die Folgekosten halt enorm.
Ja. Wir haben eine Wortmeldung noch, das soll die letzte sein. Vielen Dank.
Ja, der Sebastian Karl war auch von der C4D als Automobilist. Darf ich vielleicht einmal ganz kurz zurückschießen? Und dann habe ich eine Frage. Ja? Also wir haben vor 1,5 Jahren circa, habe ich mit so echt super Top-Uni-Absolventen und ein paar Studis ziemlich stabilen PowerPoint-Generator gebaut. Ja? Also der das automatisiert, der mit ChatGPT Bilder, Texte und so weiter einfügt. Und dann haben wir gehört, okay, der Co-Pilot kommt, Also wir werden damit nicht ausgründen und Milliardäre. Und jetzt haben wir uns den Co-Piloten angeschaut und haben festgestellt, wow, ich bin halt mit einem kleinen Team anscheinend sehr viel schneller und besser als diese großen Konzerne, weil der Co-Pilot kann es halt immer noch nicht so richtig. Das heißt, auch Microsoft hat da so seine Herausforderungen. Und meine Frage ist, ja, wie schaffe ich es denn, das, was ein kleines Team halt viel schneller, viel besser anscheinend kann, das so zu skalieren, dass Produkte rauskommen, die halt für ein paar Millionen Leute auch wirklich funktionieren. Weil das wäre vielleicht auch die Antwort auf die Fragen, die wir jetzt uns stellen. Wie können wir einen VW, einen BMW wieder auf Geschwindigkeit bringen? Mit der Carriot vielleicht.
Vielen Dank für die hervorragende, aber nicht leicht zu beantwortende Frage. Möchte noch jemand etwas dazu jetzt sagen oder sollen wir darüber sinnieren, was ich vorschlagen würde beim Mittagessen? Okay, Sie sind alle eingeladen. Jetzt, wir sehen uns gleich wieder hier. Vielen Dank.
Gerne.
Vielen Dank.
Nochmal. Liebe Gäste.
Ja. Okay. So let's go on with our program, and please welcome our co-host and next speaker, Markus Baum, Senior Partner of Roland Berger.
Thank you, Oliver, and sorry for disturbing the funny part of the Congress, the lunch and the networking. I would like to talk about the things that we as a company and myself have realized the last 2 years in many projects for the several vehicle manufacturers on the passenger car side as well as on the OEM side. Here we go. 4 things that I would like to discuss a little bit. Okay, what are the frameworks in which we need to work in, comparing the past to the next years, at least our view. Then looking a little bit more ahead, what needs to happen and should happen and will happen with most of the OEMs until the end of the decade. What are the implications out of these decisions that are made now? And then one negative aspect that we realized in our work for several OEMs. They all aim to do everything on their own. And if you look to the cost structure, this cannot be a good solution. So I would very much encourage everybody to have something against it. We've been monitoring the market for automotive software very closely since 7-8 years. And looking at the last years, it had been paradise for software development. I want to have something, you will get the money. There's a problem, you get people, you get money, was not a problem. Consequence, the thing become more expensive every single year. The last year we saw in average across all OEMs between 10 and 15% budget increase for software development. Fantastic times. But when looking possible that are just the R&D spend of all the players, and you see they only see one direction, especially for the Germans. It's crazy what they spend for software development and development in general. A little bit more cautious, the Asians, with the only exception BYD. But BYD, they kept basically their R&D share constant. They just grew so badly that they could afford to do so. Welcome to reality. This time is over. We will not see the next years that the budget can increase with the same speed as we have seen before. But we need to do the change, the transformation. We need to do the transformation with less money than planned the years before. And this is true across all the Western players. What's the ambition that they all have? I mean, we talked to basically all the OEMs the last 18 months. Summary of the vision. We want to have a central zonal architecture, having 2-3 high-performance computers accompanied by 3 to 4 zonal computers that do decentralized power distribution, channel communication, and do a little bit of consolidation of ECUs. And there will be a very high level of hardware-software abstraction so that you can develop a software to a high degree independent from the hardware underneath. It will not be possible in all areas. Even if there are single players out there that say, okay, I have a solution where I can abstract the software from the hardware for the entire vehicle, most of the OEMs have doubt that this will work out. Reasons to do so? It will be more cost efficient. Engineering will, over lifetime, cheaper. Yes, you will have a peak in the beginning, but over lifetime, the one-time efforts will be significantly lower. Due to the new EE architecture, you will have significant savings, or can achieve significant savings on the material cost side, cheaper wiring harness, less ECUs. And especially for the German OEMs, the last thing is important. Faster time to market. They realized if they stick to their old processes, they will never ever be competitive with the Chinese. But the thing is massive. That's the reason why we aim for the very right-hand part, coming from the left-hand side. So that's the reason why we see a more gradual involvement. Okay, let's do the intermediate step with having a domain consolidation, taking out a few ECUs by doing this, and then in the next generation, do this step. This has a lot of advantages in terms of what needs to change. I mean, the changes on the central zonal approach with having one big software stack on the HPCs is a major one. So there are good reasons to do this intermediate step. And following up on the discussion that we had just a few minutes ago, looking at the Chinese, you see they are moving rather quickly and following the example that Tesla set already in 2017. But even the French and the North American OEMs are more progressive than our Germans. If you look at the timeline, they are about to change now towards a domain centralized approach. VW is there, Mercedes and BMW will follow the next year. The next step, the next iteration, will take at least until the end of the decade, and even there's a huge span. The Chinese, on the other hand, you see very progressive, very early on the final solution, central zonal with a hardware abstraction. Yes, there are a few that say, okay, I need to do smaller steps, but even they iterate faster than the Germans. This all is coming with quite a hefty price ticket. That's from the interviews that we did, just one result. How much does it cost an OEM to do the transition? Coming from 1.2 billion US dollars or euros in software development cost, mid of the last decade, now to roughly 3 billion, so basically doubling the engineering efforts. That's the consequence of saying, okay, I want to do this step. Coming back to the things that we discussed at the beginning, you need to do now this investment in a time where the money isn't that easily available. This US OEM did, from my point of view, a quite interesting approach. The lower part, they kept the old legacy software running and spent quite a significant amount of money. And then they afford themselves, since 2016, to have a very parallel team with own processes, with an own organization, with an own budget, to bring SDV to life. But you see, doubling the engineering efforts. In parallel, the investments that you need to do on the tool chain, on cybersecurity and cloud services. Cloud services, it's not to run the cloud, just to develop the tools for the cloud. It's quite a massive investment. From all our findings, the thing that me personally found interesting, everybody's saying the commercial vehicle guys, okay, laggards, they do everything way later. If you look at the timelines, boy, they are quicker than the past car OEMs. So it might be a good way for all the people in the PESCA industry to look at what they have done, and they have done it with significantly less people and significantly less money. Speaking about the amount of change, from our point of view, there are a few things that you need to do. I really say need to do. First, you need to change your organization. Have at least, on a project base, one software organization that has cross-domain responsibility, cross-functional responsibility, end-to-end responsibility, and responsibility over lifetime. The responsibility does not end at SOP, it goes on. You need to develop the HR tools, you need to hire new talent, to build up new competencies, you need to develop a career path for those talents. You cannot stick them into the automotive pattern, that will not work. You will not keep the talent that you have once acquired. That's the organizational side, but also on the process side, there are major changes required. The most important thing is take software out of the usual product creation process. It's a different thing. It needs to be independent. It needs to be planned completely independent. Then there needs to be some synchronization. But you cannot do it as part of the overall vehicle development process. You need to have a system engineering approach, otherwise you cannot control the complexity. You need to have agile processes with all the DevOps that's required. And the thing, Matthias, that you presented at the beginning, you need to measure performance. Otherwise, you cannot control this thing. Quickly on the organization, the easiest way is to say, like Mercedes did, do a project organization. Have somebody responsible for the entire thing, but keep a big part of the people within the existing organization. Just on a project base, try to centralize them. The more radical, and in the long term, the more viable solution very likely is the thing that VW did with Carrier, that Tesla did from the beginning, Volvo is doing, saying, have one organization responsible for all software and most of the electronic development. Knowing that this change is really, really, really massive. This is not a process that happens like this, it's a process that takes many years. I said, okay, I would also talk about one negative aspect that I have realized in all our work around SDV movement. If we map different OEMs on how advanced are they with regard to SDV approach, how much functionality do they have, how much organization advancement do they have, and try to cluster them. And then look on the other dimension, how much software do they in-house? And you see a very high correlation. As more advanced the OEM is, as more software they tend to develop in-house. Would be okay if this would be a static picture. The problem is, everybody wants to be on the upper corner. So that means everybody is trying to build up resources to develop a very high share of software in-house. This made sense for Tesla, saying I have something unique, where nobody on the outside is available to help me. But now companies like BMW, Mercedes saying, hey, I want to do 70–80% of my software in-house as an ambition. I have doubts that this is commercially wise the best solution. The problems that we very often hear is, I want to have the IP rights, I want to understand, and I want to optimize the systems. The easiest way to do is if I do everything in-house, not knowing or not really thinking through the consequences of having 10–15,000 people in software development. And there are a few examples out on the market that show from the coordination of such a big software unit, it's not the easiest thing to do. And one solution that we believe is you need to have different approaches. One thing could be or should be open source, taking away a lot of the constraints or considerations of the OEM, saying, I don't know what's in it, I don't own the IP. Open standards will also or should also contribute, and there will also be new models. I mean, Jeff is here saying having a new platform to really try to commercialize automotive software in order to make the entire thing work without blowing the entire engineering budget required. Thank you very much. My 15 minutes on what we see will happen and should happen the next years on software development. Any questions, comments?
Thank you very much for your insights, Robert Fye from Synopsys. I know CARIAD quite well, and I've made some own analysis about how Tesla is doing it.
Yeah.
And what I recognize is that Tesla has pretty less people in the development according or in comparison to VW Group. How could you explain that with your graphics? And
you're absolutely right. Depending on the people that you're asking, they have a fifth or a third of the people that compare to CARIAD. One reason for sure is that they have the right processes, that they have the right culture, that they have the right talent. The other, not to underestimated part is the complexity. Tesla is a one-product company. They have one E architecture in 4 generations. Looking at the VW Group, it starts from the Polo, or the up in the past, up to a Porsche and an A8. So the complexity of the software is there. And I discussed with many of my OEM clients to say, okay, for this variety of vehicle requirements, to have one E architecture is close to be impossible. So they did a lot of things right, but they also had, Tesla did a lot of things right, but they also had very easier framework conditions to innovate into this thing. I mean, for a premium OEM, like BMW, Mercedes, everybody said, okay, we need to have at least 2 parallel E architectures, otherwise the thing will be so complex and there will need to be so many different branches, or the entry-level vehicles will have such an expensive EE architecture that the customer is not willing to pay for it.
Are there?
One short question. Thank you for that really nice presentation. Actually, the software-defined vehicle should be a framework where we can easily work together.
Yeah.
And now your analysis revealed that these companies who are far ahead with software-defined vehicles do everything in-house. So what's wrong here in the game?
I mean, we try to get together with Oliver and Seerene to test out the idea of having software expert boot camps with executives in the automotive space. There was no interest. And really, in the meantime, I believe this lack of experience is a major problem. I mean, you cannot justify such a thing. You need to believe in things. And everybody who has done radical changes believed and stood for it. I mean, you cannot argue or argument a thing like a CARIAD. You need to believe in it. So I fully believe into the concept of a CARIAD. The same thing true with the changes within Mercedes. There had been key persons believing in this transition and making it happen. Otherwise, it will not. And we need to, as a community, we need to say, okay, software works completely different than hardware. And by repeating it constantly, maybe there will be some willingness to open up and to really try to understand what are the different requirements.
There's 2 more questions.
Yeah, just an information. We analyzed about 3,000 job descriptions of Tesla worldwide about engineering in the engineering department, and to us it didn't look like they have so far away development process that we have. I don't know what's different, but it has been, as I said, 3,000 using the same tools as we do, except ours.
Hello. So Jeff from SDverse,
Yeah.
Detroit, Michigan. Just a question about where the ecosystem in purchasing is moving. You talk about the engineering. Maybe you can shed some light on the European purchasing departments and how they're seeing as they purchase more software. What are they doing to adapt to this new normal?
First, the most important thing is the software purchasing should be part of a software unit, not be in the purchasing department. And if you look into the things that the Mercedes has done, that the VW has done, they have already implemented this one. And as I said, end-to-end responsibility, ideally there are part of this team responsible for a certain part of software that's not centralized, not somehow away, but it's really a crucial part of the software engineering part. And then you can also way easier coordinate with co-development, the large-scale agile teams with third parties, suppliers, software vendors, so that we really split up the old structure, becoming more part of smaller agile teams. Any other questions?
Yes, I have one question, Evgeny from Volkswagen Group. You showed the graph that Volkswagen tried to catch up to Tesla, in-house development. Do you think it makes sense to do that, or do you think it's a good mix between in-house development and sourcing? So what do you see the break-even point? Because when you have to accelerate from 20 to 80, it's a very far way to go. So maybe it's a mix between both. Or do you see
I'm not an advocate for saying to do everything in-house. It makes cost-wise no sense. You redevelop something that's already there. And by reusing it, it will always be cheaper. At the moment, there's a big but. If you transport one functionality from one EE architecture to a next customer EE architecture, 60–70% of the costs occur for minor engineering changes and for an enormous validation process. If you have some kind of standardization and middleware that is similar from OEM A to B to C, this model perfectly works. But there's some willingness from the OEM side. I'm open to say the OS, it's not differentiating. I'm willing, as CT Tech, let's agree on one standard that everybody can accept. I mean, as soon as the fundamentals are there, cross OEM middleware or hardware abstraction layer, then go for only the differentiating part for you as a brand and purchase the other stuff. Thank you very much.
Very much for this dense and smart presentation, Markus. So let's go on with another co-host. Please welcome Dr. Inga von Bibra, member of the Executive Board of Microsoft Germany.
Yeah, thank you, and welcome to our premises here in Berlin. I always find it's a very nice venue, not too large, not too small. I hope you had some good conversations already in this really interesting topic. I would like to share a few things about general AI with you today, and also the impact it already has and it might further have on the automotive industry. And maybe before we go into more detail, doesn't click. Try again. Regie. Here we go. I would like to just show some of the current activities with you. This is a construction site of a data center. Question for me to you, do you roughly know how many data centers currently are being built by Microsoft? Any ideas? Any order of magnitude? 5, 10, 1,000? 15? 50 per year, you're saying? Or what time frame? 20 per year, okay. Well, you know, AI is a key topic for us, and we're really, really in with attention on that, and that also means investments. We're actually building 120 data centers in 12 months. So if you break that down, I mean, they're all the size of a soccer field, several soccer fields typically. They're around 400 to 500 million to build them. That means every 3 days, we are opening a new data center somewhere in the world. Means also per week, roughly an invest of 1 billion euros. So that's also, we've become, I always like that fact, we've become the biggest construction company, I think, in the world. We kind of have 120,000 people building data centers. So that's certainly not in-house capacity. We're outsourcing that, but you see the magnitude. And it's just not a magnitude of invest, it's a magnitude of demand signals that we're receiving from the market. So is AI really the next big thing? And I would like to put it a little bit into context. There's certain technologies, looking at almost the history of humankind, there are certain technologies, they're called general purpose technologies, that have a very fundamental impact, a really pivotal impact on economies, on a global scale, international scale, and really change society and the way we work. And what you see on this slide is that there's two things that are accelerating rapidly. One thing is the numbers of innovation and the acceleration of innovation cycles. See, you know, when you start off printing press, 1480, can't quite remember, and then the number of innovations in recent times, and also the impact it has on GDP growth. So what we see, it really has impact on the growth in various industries. And the typical examples for these general purpose technologies are that they don't affect just one sector, so you get better by inventing something. They actually affect multiple sectors. They also have something that's called a spilling over effect. So it's not just helping to benefits in that industry where it's been invented, to benefit to the business there, to benefit to innovation, but it actually spills over into other segments as well. So a typical example, if you think, let's take the steam engine, or let's take electricity. When electricity was discovered, Benjamin Franklin probably thought, well, that's a cool thing, but did not have completely in mind what it does with us, all the way now to leading up to us having smartphones. And the third part, and I think this is very important to keep in mind in this transformation that we're facing, these technologies, they have a lot of difficulty in the transition. So there's a lot of overhead, difficulty getting it started. Think of railroads. So you invent the steam engine. The time we actually built railroads took some more time. Back to electricity, it wasn't just the flip of the switch. There was light, then we needed to put in infrastructure. Where does the energy come from? Power plants needed to be built. And it also means it's a change in technology. Technology becomes obsolete with new inventions, but also a change in skills. Once you drive cars, you don't need horse riding anymore, or you don't need as many, let's say, typical typewriter, all the writers who wrote things by hand. And I think this is something that we're seeing also with AI at the moment, because it automates things, it changes the way we work, and there's quite a bit of change in the system in terms of what technology will we continue, what skills will we continue, and are we fast enough in building the new technologies and the new skills. So the answer looking at this, is Gen AI, as such, part of these general purpose technologies? Yes, it clearly is. And it will change the way we work. And it is already the fastest adopted business technology ever in history. Let it be on believing in it. 87% already believe it gives them a competitive advantage. Majority of companies have realized they can actually add new value with it. It's not just getting better at what they're doing, it's actually doing things differently, generating additional value. And if you had about cost and cost pressure, IT spend, I think in all of the industries, in the industry we're talking about here, we know that is not abundantly available. So rededicating 43% of IT spend towards AI, and that's the prediction going forward, certainly shows that there's a lot of faith and attention in this topic. And same applies to automotive companies. So the automotive companies that adopt Gen AI now, they do it across the whole value stream. So you start off, you think of engineering and design, with helping to have multimodal views on augmenting the design process, requirements, specification, requirements management. But it's also about a production and supply chain, being suddenly able, and I think that's the difference. AI is long and old, right? 1954, I think it was invented the first time. But now, with generative AI, it has changed into the way we interact with data. So we actually are able to talk to the abundance of production data there is in order to find out which plants are outperforming other plants. Where do we see certain patterns? and not through clumsy cockpits, but rather in natural language or also in natural visualizations and reasoning. Same applies to sales, service, and marketing. A lot of efficiencies, improvements for quality, and looking at the cost again, of course, also in indirect functions where there's a lot of overheads that, particularly for the European OEMs, has always been a problem in comparison to other countries and competitors. Also, there's a lot of potential here to improve this. So let's have a look at how generative AI can really, in the automotive space, help to have a significant impact. And I think the key differentiators, and I liked your presentation on also in the Americas and in the Asian space, what we see is what is key in terms of being successful is fast innovation. So far, we are not that fast in terms of innovation due to complexity we need to manage, regulations we need to manage, and improving there, absolute key. The second one is also how fast are we getting features into production? That's on the hardware side, but also on the software side. How fast can I, over the air, update a vehicle without actually causing a safety issue? How differentiate that in the architecture? Customers have different expectations, and coming from a traditional 7, 8, 9-year development cycle of product development, the new competitors have significantly shorter cycles of 2, 3, or 4 years. And of course, in terms of operations, customers expect a different dialogue with their, let's say, their vehicle, their hardware, similar to what they're used with their mobile phones. And also that, let's say, customer centricity in the way product and OEM look at the customer, rather than coming from this traditionally quite engineering and product focus of German OEMs. So if we look at, for example, at requirements management, you know the challenge, and you also know how complexity has exponentially, almost like blown up over the last few years. And this is also because there's, first of all, even on the mechanical and the regulatory requirements, with 50,000, that is a lot to deal with. With the software and electronics requirements, we're talking 500,000, and if we now look at the lines of code that we need to manage in modern vehicle software, we're talking 200 to 300 millions. I think I looked up the first Volkswagen that was built, had something like 2,000 lines of code, and that is a complexity, I think, that we see where processes, systems, and people are struggling to keep up. So 8 hours per requirement for the standard requirements engineer to deal with that, from draft to review, refinements, and we also know that tool chains aren't always integrated. There's a lot of manual work also moving in one tool chain for the E-part to the other one for software and so on. With generative AI, this can be reduced by at least 20%. It helps to automate interface, it helps to have smart suggestions on how to proceed, on next best definitions. And interestingly enough, a lot of the generative AI tools that people are using, the first point is always, yes, it helps me to increase my productivity, but in truth, after experiencing it a little bit longer, it actually number one becomes, it helps me to deliver better quality. And this is the case in engineering. This was a case also from a more on the financial services side, where people said, it really helps me because I can bring up my quality. And of course, also, see a little symbol down there, the time saving in software development, because a lot of these actions, it's actually not something that engineers are paid for or qualified for. It's the boring work, right? It's in software development too. It's like documentation and retesting and copying the code and putting this and linking that. So with intelligent Gen AI tools, you can really bring the fun back to the developer community and help them to focus on what is truly important and what also corresponds to their core competency. In product design and development, if we see that very significant global R&D spend, obviously there's a huge potential for savings and efficiency. And we start from the right on the slide. I mean, it's not surprising. Engineering executives, I think every executive will always tell you, oh, we absolutely have room for productivity increasement and so on. But if you talk to engineers, I mean, they really struggle. They really struggle to meet their timelines. They struggle to have the pressure and integrate everything. There's great studies showing that 51% of automotive development projects are over time and 44% are over budget. And I think everyone has probably experienced that reality in the industry. And that is also because 59% of these engineers, they spend their time on non-value adding tasks. So just imagine what you can achieve if you just take half of that away from them and reinvest that in the increase in productivity and the better reuse of that R&D budget that's there, that can go into new features and reworking architectures and being more competitive. And last but not least, customer service management. I believe closer linked to software than we always think, because a lot of data around the customer and around customer service is information that we need from the vehicles that come out of the cars. And there's a lot of efficiency and potential in both quality as well as handling time across the process. Because agents, I mean, we all know it's probably a job that is super stressful, inconsistent service, and also as people, we actually sometimes don't even want to talk to people. We just like having that chatbot on hand. We get predictive service, we get a single source of truth, and we can do it at our own time, and it scales, right? You don't have to be in a call center line for 10 minutes because everybody's trying to call. You can just talk to someone straight away. So there's also a great potential there. One thing I would like to add, we tend to talk a lot about efficiency and also about quality, and we think of these Gen AI tools, which they currently are, or applications that we build, in a first step around your own, let's say, area of work. What's happening, though, you have to imagine these Gen AI products as agents. So when you think of process automation, think of like a virtual colleague that's basically running a similar job in the background, talking to other agents. So you can imagine an engineer in R&D talking to an engineering agent on the production side to get that interface straight between R&D data and production data, for example. You can think of, in the finance department, an agent helping to analyze the data and also then trigger action in other agents and other departments. So it's not just stupid process automation, it's the intelligent behind it that takes a share of business processes out also into this agent world, which then again helps to help scarce engineering talent to build this, to transfer more into their core competencies and go back to adding the true value that everybody's been educated for. So the impact goes along the complete value chain. I've touched a little bit on engineering, but you can also see that in blue screen, I guess my time's up, but it's nearly finished, across the value chain with significant improvements there. And you would be surprised to see how easy it actually is with data scientists and the right language models, even with smaller language models that don't need as much compute power, that are faster, to build these agents in the requirements engineering space. We have seen some cases where a consulting firm managed to, with just 4 data scientists, build a really interesting agent based on an open source model. So people are getting started, and I think we'll just go to the next one now. We talked about the traditional hardware-oriented industry here, and we also had a look left and right into software and also the new competitors. I think it's an exciting future that's coming up, but it also means it's key to embrace the technology now. People are already doing that. Companies are doing that, competitors are doing that, other countries are doing that, and I think the democratization of AI with this, also in this space, has already started, and I'm looking forward to seeing a lot more of this in the next 12 to 18 months. Thank you.
Thank you, Dr. Inga von Bibra. Are there any questions?
Thank you for the very impressive presentation. I have two questions. One question is, you gave us an impressive number, 120 data centers in 12 months. Can you give us a little bit more on an insight, how you decide where you place it all over that world? And secondly, can you give us a number about how much energy one of those data centers is consuming when it's in operation?
Yeah. So the decision processes, I'm not part of decision process on where data centers are built. I think we have a good example in Germany, though, that with the in the former coal area, the big investment was strategically placed simply because of an area that has labor, that has certain proximity to other big network nodes, that has also a potential to attract more industry in that space. So in that sense, here the decision was clearly made around of course there's also geophysical aspects you need to take consideration. I'm not an expert on that. So in that sense, and I think that's transferable to other countries as well, where are there also from a specific local area in terms of also driving the development of certain regions' potential, plus then, of course, the connectivity. Your answer on the electricity consumption, I can't give you numbers, don't have them. I would like to point out, though, that the ambition of Microsoft to be CO2 and water neutral, so the sustainability goals remain. Even though, of course, it has become more challenging. We need to be more creative in terms of how to meet those. But there's still absolute commitment to be carbon neutral 2025 and negative 2030. No change there.
Yeah, thank you very much for the nice presentation. One question regarding data. You have a lot of data centers worldwide. Now we have a lot of regulations also worldwide with data. How do you cope that, especially with China? And do you also offer solutions for customers so that this can be easily taken into account?
Absolutely. I mean, I think it's a top topic. It's becoming probably even more burning every day. Particularly, maybe also we have seen some evolution on the geopolitical front. For Europe, first of all, there are data centers in every region, so regional concepts for Europe in Ireland. So it's really on, let's say, sovereign space, not all hosted in the US. That's first of all, you can go into your individual regions. And then, of course, you follow the local data protection laws there as well. Same for Germany. So we have, obviously, Frankfurt has big data center, now the new one's being built. The topic of sovereignty, I think that is the key for many of our customers who also might have concerns about access indirectly through an American company and so on. Depending on the information classification, we actually have for data that truly requires sovereign hosting, there's a new offering. It's called the Delos Cloud. It's actually a joint venture with SAP to offer basically an Azure stack and an Azure data center in a completely separate non-Microsoft unit operated by non-Microsoft people. It's basically Microsoft technology, but operated completely without Microsoft. That's the Delos Cloud, and that's an offering that's on live, I think, or the announcement was made a month ago. So here we're talking customers that have extremely sensitive data. That's on similar constructs we have around the world, because you can imagine if you talk federal, if you have certain American units also, even if they're in America, they would like the federal agencies we have there, they have certain requirements on data protection. So we cater for those. In Germany, it's the Delos Cloud. In France, a similar offering, it's called Bleu. That takes care of that. So depending on information classification, of course, these things come with an overhead in terms of management and maybe a lag in terms of innovation. We advise customers to be super stringent in their information classification and then use what matches their needs the best in terms of cost and requirement ratio there. Yeah.
there's another question.
My question goes to the energy consumption, like my previous talker. Last week or 2 weeks ago, I heard that AWS in Cloud working on a private nuclear plant to supply the energy for the cloud centers. Does Microsoft want to go in the same direction?
Not that I'm aware of, and no plans there. No. Not turning into a nuclear power plant provider.
Thank you, Dr. Inga von Bibra.
Thanks.
Let's grab a coffee. Hi, welcome back to the last round of presentations, and please welcome Professor Dr. Dirk Slama, VP Ecosystems, Robert Bosch.
Thank you. Good afternoon. We have half an hour. I've prepared a little journey for you. Before we get started, please, quick show of hands. Who's making his money by using Microsoft Visual Studio? Who's coding or doing AI stuff? Okay. Who is making his money by using Excel? Okay. Who's making his money by using PowerPoint? Okay, what are the others doing? Okay, I want to talk a little bit about digital first and put some light behind this. So let's start by taking a walk back down memory lane. Who has been using this website about 20 years ago? Who has been using this website? Over there. I think the first time I've used Amazon, it already looked like this, if you remember. Yeah. So the thing to be said about these digital-first internet pioneers is that they are constantly innovating. They have, in fact, actually perfected the methodology how to innovate. So they have introduced things like design thinking, like lean startup, heavily based on early experimentation, on incorporating customer feedback, and everyday improving products. This is, unfortunately, it's in German, but I think it still proves the point. This is actually 3 screenshots from a single day where Amazon was giving pretty much the same dialogue, just changing the little button down here. So useful, or happy face, okay? Trying to figure out which button is more likely to be pressed by customers, right? Like super small detail in the Amazon jungle, so to say, yeah? But really focusing on improving their products every day using this approach. So if we try to apply this to automotive, we have a tiny little problem here. In automotive, it really depends what you're doing. If you are making your living by bringing Angry Birds into the car, you have no problem. If you make your living by bringing airbags into the car, right, that's a first time right type of thing. It's an entirely different story, okay? But digital innovation, you know, like take this airbag example, right? We see this every day, you know, the innovators, they now use in-vehicle cameras to do things like, for example, you're sitting, you put your backpack next to you, and then the car complains because it thinks a person's sitting there which is not using the seatbelt, okay? So now they're using AI to basically detect whether a person is sitting there or actually, you know, not. And it's these small improvements that make better cars, and where we have to decide on an everyday basis, is this improvement basically in the area of Angry Birds or airbags, ASIL or QM. And that's challenging because, I mean, everybody in this room who is technical knows this, right? The Kahn matrix, right? So I want to do a tiny change and I have to talk to a gazillion people, and they're not even inside my own organization. So that's a nightmare, and that's slowing us down. And then the other thing is, I don't know if you can recognize this picture. This is literally hell, okay? So this is what I would call the integration hell, okay? So basically, you go on, you do some coding, and your suppliers are doing some coding, and you think it's going pretty well, and then you start integrating, right? And 3 years later, you're not done integrating, okay? So that's another big problem that we're facing as OEMs. And then really this clash of two worlds. So I myself, I'm a software guy through and through. I spent 20 years with startups doing software, and the last startup we had was acquired by Bosch, and then after a year with Bosch, I developed this theory. Bosch has about, like 420,000 people. I think every Bosch employee has a secret tattoo on the forearm, and there's 2 different kinds of tattoos. There's either start of production or minimal viable product. You can't have them both, right? And the challenge really is, how do you bring this together? How do you bring these different cultures together? I swear, half of the previous presentation had the agile infinity loop, like, yeah, let's all be more agile, but this is hard in automotive, right? So how do we do this? How do we actually cut the Gordian knot? Well, it's actually very easy. It has nothing to do with eating better, although that helps, right? But this is very much about decoupling. This concept of the bento box in Japan, where you have this neat layout that you use to basically group similar types of food together, yeah, in different compartments where they belong, right? Creating a clean code architecture, right? And I would argue, I mean, there is no clean code architecture, or you're doing something wrong from a business point of view, but at least there are cleaner code bases, right? So if we look at what can we learn from the internet guys. So this is the combined technical wisdom of 25 years internet, right? So what did they do, right? Well, DevOps culture. Okay, so remember those days when I had this 20 years ago, working for a large German airline in the development side, and whoa, we did funky stuff, and we decided to use a NoSQL database, and we were so proud. And a year later, for the first time, we talked to the operations people and said, hey, this is cool, operate this for us. And they basically said, nah, guys, we can only operate Oracle. Go home, come back when you have fixed this, right? So that was a long time ago, and DevOps kind of has repaired this. And obviously, continuous delivery. We had the presentation from Roland Berger earlier on, and he was emphasizing that obviously we need to automate our delivery pipelines. Yeah, so high level of automation is key. And then loose coupling or disentanglement. So microservices, APIs, and containerization. The internet today runs on containers. And actually one last thing, which I think is also really important, chaos monkeys. This was actually introduced by Netflix when they migrated their architecture to AWS, and they figured, wow, we have a hugely complex distributed system at hand here, and we can't manage the complexity of this by just trying to define the state of the system as a whole. Yeah, this would be as if you were trying to fix the internet. Right? So they basically said, okay, we need to have a loosely coupled system, and every engineer in our organization needs to be prepared to deal with the failure of the other folks. The other developers are stupid. You are smart, the other developers are stupid, but your code has to be prepared to deal with the stupidness of the other developers, or somebody just plugging a cable or whatever. Okay? So make your own code, make your own components reliable, okay, and test this by actually introducing, chaotic system testing. Okay, so this is very un-German. We Germans, we like to plan stuff, right? So this is the anti-German way of testing. And then, of course, what we also have is not only the internet folks, but it's the smartphone folks. Who is a fan of Big Bang Theory? Okay, some of you. So you might remember the episode when Sheldon Cooper had this app, and he was really annoying. He was running around, and whenever something did something stupid, he did this noise with an app, right? So the whip splash sound. The developer of this app, did he know anything about Apple smartphone hardware? No. Did he know anything about how an accelerator sensor in a smartphone actually works? No. Did he know anything, how to do sound programming to actually create the sound? No. All he wanted to do was 2 lines of code. If smartphone moves, then make a splash sound. Okay? And this is what the smartphone guys have perfected. Okay? Putting in hardware abstraction layers, putting in APIs, putting in delivery pipelines, app stores, and so on. And this is where we're just starting in automotive. So again, in the Roland Berger presentation, we heard that in 2030, even in Germany, we might arrive at these centralized EE architectures and so on. But maybe we can start, as we've also learned, halfway. So let's look at vehicle APIs. This is a set of vehicle APIs coming from an organization called Covisa. And the basic idea here is if I have a vehicle API, like an API to open a door, okay, then I have these two sites, MVP, SOP. I can have basically the hardware-centric people deliver this API to me, and then I can take somebody who is a developer fresh out of university who has never heard of Khan, Lin, or FlexRay, develop a cool application with it, okay? So the basic idea really is, for example, here I have an API for a door, and I have, I don't know, Windows and child lock in it, and it reads like an iPhone API, right? Now, this kind of API I can use on the vehicle, okay? So we heard this earlier on, basically shifting functionality out of the deeply embedded layers and use maybe even container runtimes on board the vehicle, internet-style development in the car. And now I want to create a new service. So earlier on we were talking about Tesla. Tesla has this service at your house or even at your workplace. Okay, so let's say you want a service technician to have an app that he can basically open your door and repair your car for you or service your car. So what you need then here is an application running in the cloud combined with a smartphone that is calling a function on the car which is using this API. Vehicle, cabin, door, row 1, left is open. Okay? Now, another use case here might be a passenger welcome sequence. Okay? So our sales guys, they always want that customers can develop a more emotional relationship to their product, to the car, right? So I want the car to welcome me. Hello, Dirk. Adjust the seat according to my preferences. If it's a rental car, I don't know if you have this with rental cars. Last week, I had a rental car that was insisting to speak to me in Romanian. Now, I have no problem with Romanians, but I don't speak the language. And in order to tell the car to speak to me in another language, I had to tell the car in Romanian. That was pretty tough, right? So if that car would have, this welcome sequence, adjust the language, adjust the seat, and then actually open the door, I would have greatly welcomed this. So this type of algorithm can run alongside the service technician algorithm, okay? And it is also reusing the open door API here. Now, I don't know how many of you here are like serious automotive people, but those of you who are will now say, well, is that really a safe thing to have an open door API on a car? The answer is probably not, unless we make it safe, right? So in order to make it safe, what do I have to do? I have to, first of all, check that the vehicle is not moving, because I cannot open the door of a moving vehicle, okay? Then I need to check in my beautiful EE architecture with the rear camera that no motorbike is approaching the car when I'm opening the door. And then I have to check that there is, also with the side camera, no obstacle that I would bump into, okay? And only then am I allowed to actually really open the door, okay? So obviously there's a cost involved and there's a technical complexity here, and that actually brings me back to the chaos monkeys, right? So I would argue when we have systems of a level of complexity of this, it's fine to have a solid test plan derived from requirements with the help of Gen AI, as we have learned, and so on. But I think you need to combine this with these modern test approaches. Now, let's come back to food. We're talking about building blocks earlier on, okay? So we need to go from building blocks also to value streams, right? So how do we produce the food? How do we produce the software? How do we produce software where things are neatly arranged in the right compartments and so on, right? So we need work streams. We need to be able to decouple not only on the technical level, but also on the organizational level. We need decoupling, we need loose coupling, and we also need end-to-end organizations where people basically take on responsibility for a function that starts on the smartphone, goes over the cloud onto the SDV layer and then deep into the vehicle, right? So these people need to work together, but they need to be loosely coupled because they are working at different speeds, and they're also working with different safety and security parameters in mind and so on, right? So digital first really means two things in this context. It means shift north, right? Getting as much as possible out of the deeply embedded safety-related layers onto higher layers, and shift left, which means as much digital in the development process as possible. So shift north, coming back to this clash of cultures and to the distribution of software. And actually, again, coming back to the Roland Berger presentation from earlier on, that said, we need MBSE and we need agile. So anybody who has ever done MBSE will maybe agree that it's not entirely agile. And everybody who has done agile and code-centric will agree that, you know, model-centric, planning-centric, how does this go together, right? Well, it goes together if we can introduce on the technical level, you know, this separation using a vehicle hardware abstraction layer, okay? And then there's obviously multiple shift norths here, right? So we have, first of all, in the EE architecture, as we have heard earlier on, the shift away from intelligent specialized ECUs towards centralized compute, so that's a shift on the hardware level. Then we have the shift out of the ASIL, the safety critical domains, onto non-safety critical domains, and maybe even from onboard to offboard. So that's the shift north. And then the other one, that's the biggie, the shift left. So what does shift left mean? Well, shift left means if you procrastinate, if you basically don't integrate and test early enough, you will end up in hell. Okay? Integration hell. And that's simply expensive, right? So the further downstream you detect integration problems, functional problems, and so on, the more expensive it is to fix them, right? So what do we need here? Shift left. So first of all, we need user experience validation and early stage prototyping. That's really important. Early on at lunch, we were talking about, you know, the poor souls who are caught every day in, you know, managing requirements and doors and Rhapsody and, you know, so many requirements, and we can't really map them to, you know, how we're delivering the requirements and so on. So this is why I strongly believe, you know, the Agile Manifesto says the truth is in the code. So start with prototypes, use web prototyping environments, and make sure that these web prototyping environments are already getting close to, for example, the vehicle APIs. And then the next thing, of course, is system validation utilizing simulation and virtualization. One more thing is continuous integration and automation from day one, even if you have no code. Okay? But bring your stakeholders together, agree on how the process will look like eventually to integrate. And then, last but not least, continuous homologation utilizing virtual testing. So, for entertainment's sake, Robert from Synopsys, where are you? Let's talk a little about virtualization. So, I know this is a big vision, okay, but the idea is that at the end of the day, we want to have the entire car in the cloud. We want all of our ECUs, we want all of our bus systems, we want everything in the cloud for development purposes, okay? Of course, we need to have different types of virtual bus systems. We need to solve the problem of all the subsystems running on the same clock and so on. And we need to have virtual ECUs on level 4, level 5, and so on. Okay, we're not there yet, but if we can get there, then we can have a virtual vehicle in the cloud. And with a virtual vehicle in the cloud, I can do amazing stuff like cut copy, paste. Yeah? Every Windows user knows this. So instead of taking a 500 square meter hill data center, right, and paying 10 million to replicate the data center for testing, left drive vehicle versus right drive vehicle, you wouldn't do that, but you get the picture, right? We can now go in and say, hey, Gen AI to the rescue. Tell me, what do I need to do to turn this from a left-hand drive into a right-hand drive? And then actually create a clone, and then have two test environments, one for the left-hand drive, one for the right-hand drive. Okay? As an industry, we're not there yet, but this is where we have to go in order to get this complexity and integration cost into order. And of course, we need staging then between these different environments, between the early virtual test environments to the hill environments down to the test fleets and so on. So coming back to digital first, it's all about shift north, shift left, divide and conquer. And if we have this, then we can achieve this beautiful picture of software being updated hourly, using automation to basically deliver software updates, at least test them, maybe not roll them out, but at least test them functionally, updated on an hourly basis, changes to the EE architecture maybe within weeks, and everything that's physical will still take months to change, right? And this we can only have if we have loose coupling and if we have these shift left strategies in there. If we have this, then I think we have a lot of potential benefits, early customer feedback, closing this gap between requirements that nobody reads and not being able to match them to implementation. Again, I'm exaggerating, but it is a problem. And then also, of course, much more flexible build-up of test systems in a virtual world, and so on. So this is what we're doing at the Digital Auto Initiative that Bosch and some other partners co-initiated, together with a lot of other partners. If this is of interest to you, do contact me. And with this, I would like to thank you.
Thank you very much, Professor Dr. Slamer. Are there any questions around?
Yeah, thank you for this, and I fully agree. I would like to contact you later because we showed such a model that you talked about that should be there already in 2017 when we presented the Cherry XCTX project on the System Engineering Day in Paderborn. And we are far ahead of this, so this would be interesting for you to have a complete, we call it product reference model of the EE system, including all its parts, hardware, software, and also communication in a graphical model.
Thank you. That was more a statement than a question though, right? Or, okay, good. I'm glad I got it.
I was surprised about the fact that we target virtual homologation. Is German official authority also a stakeholder of this decision?
So I think what's super good question. We actually published as Digital Auto a white paper 2 weeks ago on continuous homologation. So we have a working group in Digital Auto where we have not only Bosch and ETAS, but also, for example, TÜV Rheinland, and some other partners, T-Systems, Certivity, and so on. What we can observe is that the leaders who are now basically updating vehicles on a weekly basis, they have completely changed the way how they are working with the authorities. They have, the old way is, I get the type approval, bunch of documents, and then I never talk to the authorities again for 3 years until I do the next facelift. And the leaders have really changed the way how they work with the authorities. They have developed completely different relationships, and also different systems. So this is a huge topic. I'm not insisting that virtual testing will give you everything you need to get a full approval, but it's the first step in the right direction. But it starts with really change of the way of we think about it, the processes and relationships between the different stakeholders, including the KBA and so on. Oh, I can't speak for any of them. Yeah, I can only say that I think it is important that we move in this direction.
Okay, so let's move on. We already arrived at the last speech for today. And please welcome.
Thank you.
Oh, sorry. Mr. Schlamme. Sorry. Please welcome Managing Director of Autobrains Germany, Manuel John.
Hi. Yeah, thank you, Oliver. Thank you, Mark. Thanks for having me. It's kind of a wow moment for me because 3 years ago we had the first event and I opened, I think, the conference with a content talk. And it's so fitting also today that we started with Jürgen Döllner, who talked about how AI is eating or ending programming. And now we're ending the agenda with an AI company. So it's a great opportunity for me. And I always remember the quote by Mark Andreessen, who was one of the first VC investors. He put $500,000 into Facebook. And he wrote a big article in 2011 that was called Software is Eating the World. And now people in this time are saying AI is eating software. And I will bring you an example of AI and how we apply AI in autonomous driving and ADAS. And why we need, I think, the next generation of AI to actually solve autonomous driving. So a beautiful AI and software use case from the mobility sector. So I work for Autobrains, and Autobrains, if you don't know it, is an Israeli startup. We're based in Tel Aviv, about 150 people, and I'm leading the office in Germany, in Munich. And what makes us different is that we train our software, so video perception algorithms and so on, not on labeled data, but basically on raw data in a self-supervised and self-annotated way. So when we look at the AI problem of the industry today in automotive and autonomous driving, there are certain extremes of the spectrum. And there is the middle segment of what we call some high-cost ADAS, where you have large domain controllers that we talked about today, where you have actually a decent amount of computing power and data and software, where you have a lot of sensors that can handle these high-cost and high-requirement scenarios. And you have also the robotaxis that you can already drive in San Francisco and other cities now that have a lot of sensors, radar, LiDAR, 17 cameras, but they are geo-fenced. So in these inner segments, the actual AI problem is a bit more limited, I would say, or you have helpers to reduce the AI problem. And then you have these two ends, these are the extremes on the very low segment, what we call affordable safety, where you have an AI problem to make, or to use the AI to make a car safe or autonomous with just a single camera. So you have to have very, very low compute and very low memory just to enable one single camera that's sitting in the windshield to make a system work at 1 TOPS or 3 watts. And there are very, very few players in this segment. And this is the segment that we focus on with ADAS, where we're actually also going into production end of this year in China. So this discussion for me is very interesting because also for us, the first SOP as a startup in this segment is actually China. And then you have the other end, the extreme, and this for us we see is still not existing, so there's no viable or mature solution yet in AI, this is not solved yet, is how can we make autonomous driving happen not only in a geo-fenced area, but in a much larger operational design domain with the few sensors that we have available in the car. And there are two approaches that you see today in the industry from an AI perspective. And the first one is to break down the problem into different modules. So the system architecture is a modular architecture, or some people call it compound AI system. So you take the sensor input, radar, LiDAR, cameras, and you break it down into a perception task. So you describe what objects am I seeing, how far is the object, and then you add the localization. Mapping is another module. You try to understand the path of the different objects, you're planning, and then you're sending this to the control. And this is where is an approach that is coming from robotics, and I think in automotive is now a couple of years old. And now we're seeing in the past 6 to 12 months that a lot of the AI players in the field are switching more and more to an end-to-end approach. So this means instead of breaking down the AI problem into these single modules, I say there is an end-to-end network in which I just train on basically sensor input and actuation input. And instead of just recognizing every detailed object, I train this model end-to-end. So this is famous for Tesla here because they introduced this with version 12, FSD v12, and tried to improve the system there. And famously, Elon Musk said they threw out 300,000 lines of code doing this. But we believe that each of these solutions also have their inherent problems and are maybe not the ones that help us get to autonomous driving. And I'll explain why. So why is it difficult or to reach this goal with the compound AI system? There's two problems. So on the one hand side, you may have too much irrelevant information. And on the other side, you're actually lacking information when we are talking about detection. So even with our systems that we train on large data sets in an unsupervised way, you will have a lot of information or detections in the picture that are actually not really relevant from your actual driving tasks, right? So I could say, why do I care about an object that's, if I'm driving 30 kilometers per hour, that is 300 meters away, and why do I have to have a 99% accuracy of detecting this object? And on the other side, there are situations where, from the perception perspective, we would actually like to understand much more, but we have a lack of information. So what is the intention of this child in the image, or the person working there? Will he open the door, yes or not? And we don't have this information from a detection perspective yet. And so the perception and the planning is actually decoupled from each other, because it's a modular AI system. And on top of that, even us doing this in an unsupervised way, there's a huge task of data labeling, so annotation services for text, for the video data, for the photo data. So there are competitors of ours that have thousands of data labelers sitting in low-cost countries and actually putting bounding boxes on different object classes like pedestrians, cyclists, trucks, vans, etc. And there's a massive data need, so there's petabytes of data floating around that needs to be structured, annotated, etc. And there's a huge cost of labeling this data, and it's also prone to human bias and errors, even if you semi-automate this in a way. So there's quite a few problems with this compound AI approach. And on the other side, also this end-to-end architecture that I showed to you, where a lot of players are gravitating towards now, also has some inherent problems, because it is a black box. So when you look at the video of Elon Musk, when he introduced this FSD12, it's actually an entire 40-minute ride that he posted on his platform X. You can scroll to minute 20, and the car is actually going over red light. And the system has never learned what is a stop sign or what is a red light, but it's basically all trained on data and good driving behaviors from good drivers. So now if this intervention happens, you now need to go back into explaining why did this happen in this situation. So you actually have then now a data explanation problem and a traceability problem, that you need to go back to your data set and find this, what caused this issue, because it's not explainable in the sense that because it's an end-to-end network. And the way that now everybody is trying to solve this is solving these edge cases and these last few percents of these edge cases. And from our perspective, we believe that also this approach will at some point hit a wall. Because it's kind of insanity to do the same things over and over again and then to expect different results, right? So because you have such edge cases kind of diluted in your data set, so you're trying to solve this last few percent, but it's kind of exponential what you have to give into the system. And the system is always designed to reduce the average errors. So almost by design, these systems, you can expect them to perform very well on the average, but it may not perform very good in these edge cases. And we're doing similar things in automotive now, like we're doing with large language models, where there's a purpose for this, is to say, let's scale this even more and let's throw more data at the problem. Let's throw more training at this, and we saw the 120 data centers that are being built. It takes more energy, more compute, and just by adding more and more and more, we hope that this error here will reduce, but it's actually an exponential problem that we face here. And so by design, this is very, very difficult to solve. So if these two approaches have their limits, what we at AutoBrains like to do is to look at humans. And I had this coffee chat with someone and he said, actually, I'm not such a bad driver. So if we can reach the human level of driving with my eyes, we would actually be already in a very good state. And I have to agree to some point because driving is really a task that is still designed for humans. And these human driving features, today is the human brain is the best reference for good driving. So now, even when you look at this sign here, you already know, like, it takes you a little bit, right? But with your human eyes, you were able to understand and grasp where you want to go. So let's have a look at how systems are designed for humans and try to mimic this. This is what we do at AutoBrains, and we believe can be the next generation of AI. And there are two observations for the human, from the human brain that are interesting and that we want to use in our AI approach. And then the first one is that we have holistic understanding, and the human brain is very, very adaptive. So it can adapt to different situations and has single intelligences for very specific things. So also you as a human, you don't have one end-to-end network to use ChatGPT, to play guitar, to use Excel, or to drive. So you have single intelligences, like we think about that, that still enable you to see the whole and be very adaptive. And the second observation about the human brain is that we have billions of neurons, but we're not using all these neurons all the time. So they are not spiking and firing on all cylinders in billions of times in your brain. But if you are in a new situation, it's only the necessary, only the relevant neurons that you use. And your brain has figured out which neurons to activate in which situation. And this is actually a sense of your brain has learned how to route the task that you have to the correct neurons. And this is also something that we use in our technological approach. So to sum that up, there is the compound architecture, the first one that we showed you, where a lot of the safe ADAS systems are still built upon, that we will still see. So where we also, for example, provide perception solutions for single cameras, and our tier 1 partners implement then the driving functions. And we see now these lots of players that try to solve this long tail edge problem with a single end-to-end neural network. As said, from our perspective, this is going to hit a wall. And we now want to introduce a new kind of AI approach to solve this long tail of the edge cases. And this is what we call scalable or modular end-to-end networks. So these are skills that can be added for edge cases over time, but they are end-to-end networks, but they are tuned to very specific scenarios or tasks. So think about, you want to have one skill that you have to solve the edge case or the case to drive into a roundabout. Or you have a certain skill on how to overtake a truck. You have a skill on how to drive in the best way through the rain in Berlin, in narrow streets. And then we have a network of these agents that we call skills. And these skills can learn new things over time. So you can add more and more skills over time, the more edge cases you have. And these are narrow end-to-end AI trained agents. Coming to this virtualization also that we saw is perfectly fits into this software-defined vehicle approach. Or actually, you now have to say it's an AI-defined vehicle approach. So instead of having in the monolithic end-to-end architecture where you learn new situations and now need to retrain the whole network and do an overall software update into the car, you can have multiple skills to be added over time without really retraining the entire thing. So you can gradually add skills. So you can imagine that, for example, your car today with this technology would be able to drive in an unsupervised autonomous way already from Dresden to Berlin. And maybe it also knows how to drive autonomously unter Linden, but it doesn't know yet how to drive autonomously in other areas of the city. But the more it gets exposed to different edge cases in the city, you can add these skills over time. And you have singular updates for these skills. So how this works then from a system architecture perspective is that you get a sensor input and the perception router understands the scene and picks the right skill or the right agent for this scene that has the best capability to solve this task, just like your brain does, and it pulls the information. So you have still the sensor input and the actuation that goes to the car as an output. And by that, you have really a broad network of skills, and you only use the skill that is relevant for the situation. And I will just run the video so how you can imagine this, and we did this with our vehicle in Detroit. We tested this, so you see here situations where the car is driving, and you have this ensemble of narrow AI agents, and the perception router is trying to understand which one has the highest confidence to deal with this situation, and then the perception router picks this skill. And so we've implemented this now in the car and with some of our automotive partners for different driving situations, for example, to come to a stop with a stationary vehicle that's preceding us, or to overtake. And we have these very specific scenarios for which we then train still end-to-end the agents. So we didn't break this problem into a compound AI system, but we said, let's train end-to-end for this scenario to keep the lane, to overtake the cars, to be going in and out of a roundabout. And the system performs quite well, even if you give it the same task, but in a different setting. So then speaking about the, I think we had the first conference 3 years ago was called Software Factory, and now there is this term AI Factory, which NVIDIA, Jensen Huang also promoted at one of his conferences, and where we believe a strong trend is going to, that you will find more and more players that are actually building AI factories to help their clients or partners build their own AI. So this is a similar principle here, because we realize that a lot of the OEMs or partners that we work with, they want to have IP ownership over their autonomous driving stack. So we don't develop our autonomous driving stack ourselves, but rather we give the OEM what we call here a skill factory to then take the data from their own fleet using our IP of AI, and then develop their own AI agents or skills and train them homologate them, validate them, and bring them into the car. So in the shadow mode, you can test it virtually, and then you can have different modes of autonomous driving. Some areas you will still drive supervised, so the driver has to be attentive. And in other areas where I already have the skill to drive autonomously, the system will take over by itself. So it's a much more flexible approach, taking the AI to the road and to implementation. So to sum up, why we believe this approach is the future for us is that you really optimize these end-to-end networks to the edge cases. Yeah? And you also have then explainability because you know which skill was used and why. Since you're not using a big deep learning network, it also has much lower requirements to the compute. So only the agents and skills that are used, you can basically put them into a cache, can be executed in the right time, in real time. And you'll have much shorter learning cycles and incremental learning into the AI systems overall. So I hope I was able to give a nice AI use case from the real world that's also software-based, and hope to have a good discussion with you. Thank you.
Manuel.
Yeah, thank you for the very interesting talk. Two questions. How do you know which kind of model is really suitable for the situation, how to assess the situation? And the second question is, if in the situation something surprisingly occurs, so the model doesn't fit anymore, what happens then?
Mm-hmm. Yeah, so it's similar to the human brain. You learned over time which skill to use. So similar here, we train the perception router, and it gives you a certain confidence intervals for the different skills. So the best skill that you have available is outputted by the perception router, which is also trained.
Hier gibt es eine Frage.
I have a question regarding the edge cases you talk about. So do you have a segregation between driving on the highway or driving in public, for example, in Berlin, in the city? This is the first one. And the second one, you talked about the accuracy, 99.5%. Do you have a target goal which you want to achieve with the error rate? Because it's quite high, so maybe heading Six Sigma that you say this system is able to handle every situation, is driving everywhere and doesn't matter where.
Yeah, so I mean, what we do is we basically break the problem into a finite set of skills, right? So it could be that in the end stage, you have a system of 300,000 or 400,000 of these skills that enable you to drive autonomously in many areas for 99% of the time. But the approach I think is a different approach, is to say, let's democratize autonomous driving and bring it to the streets as early as possible in a safe way for the areas that we are capable of doing it and the situations that we know we can handle with the system. So it's more of an incremental learning approach. And of course, you can use the same metrics like disengagements per x 100,000 kilometers, etc., etc. But it always depends on where are you using the system, right? And today we have AI systems that are geofenced in very limited areas. And with this approach, we want to take it further and increase the operational design domain continuously by adding new skills over time.
Yeah, thank you very much. Great presentation, and I also understand the beauty of the whole system and the setup in general. I think you were just talking about that the number of skills you were looking at would be in the 100,000s, kind of this one. I'm just thinking about like how do you manage then to have like the integration or like the collaboration of like you will pick the one skill or the other or maybe a combination of skills and so on. So like I guess there's also a lot of interface work and which needs to be solved. And I'm questioning like like how is this interface work, integration work kind of in real time being operated, and do you also can elaborate a bit about the computing power you might need, which I would assume is going to be higher than a monolithic setup? So it's going to be
yeah, sure. so the goal is of course to use less compute than a monolithic setup, because what you see there is similar as with LLMs, right? The training models are getting bigger and bigger, so you have more and more billion parameters in the next iterations of the model. And here the idea is to say, I don't need to have such a huge deep learning. It's not a very deep model, but it's actually quite narrow and model trained end-to-end for a specific task and scenario. And then I only use these skills that are needed in this moment in time. So what we did there, also in the implementation, it uses much less compute actually than if you would run a complete deep learning model on it. And then the question is, I think, of course, the question is, what is a skill? So how do you cut or define the skill in such a narrow way that it's perfect for the situation, but that it's as broad as possible then to cover the situation, or as many situations as possible. And that's a bit then the trade-off for the sparsity of the model.
Yeah, thank you, Manuel, for this really intelligent, novel approach. Really like it, because that's much easier to validate than the other one. But 2 questions, if you could go back to slide 12.
With the help of...
If that is possible. So there was a nice picture, and actually just that I really understood it. So you do not have a core. It does not only, you do not only take the agents for the edge cases, you have only agents. There is no core, which covers, I don't know, 99% of the normal driving situation. So the entire system runs with agents, if I understood that right.
It runs with agents. Yeah, it runs with agents.
Okay.
Yes, sure.
And then the second question, what happens if 2 or 3 agents are totally convinced that they have to overtake at the moment? What will you do then?
Yeah, you need to have a redundancy, of course, then in the system to revalidate it. Yeah, so this comes by the design of the system. That's also something that comes then with the confidence intervals between it. So you can try to simulate this, and then it's in the validation process in there. But you still have then explainability in your approach. Why did it do this? And then you can still optimize it. So by design, we believe this is a much easier way than to do this basically in a monolithic way. Yeah.
Oh, yeah.
So you really exchange models during runtime in driving?
Yeah.
Cool.
No, we did have a base model, yeah, so that what Matthias asked, that takes over basic driving tasks. And then we had in the collaboration that we did with some of the automotive players, we looked at specific scenarios. Yeah. And so we overfitted certain skills to these scenarios. And now we want to take it to this next step, yeah, and add more and more scenarios to this. So of course, also this system will be exposed to more and more edge cases, and will see edge cases that it never saw before. But for that, we train specific skills and agents. And for the new situations, we'll have some confidence interval that a certain skill will fit this in the best possible way. And this is how we want to reach this problem.
Okay. Please be aware, it keeps us from the beer.
Okay. Very short. The first application in China you're talking about, can you say something?
Yes, so that was on the other AI spectrum that I showed in the beginning. So that is, we're providing perception software into a smart camera. So only with a single camera we provide ACC functionality, autonomous emergency braking, lane keeping assist, traffic sign recognition on very, very low compute. So also there, we already see with our AI approach how that we're using very low compute, we're very efficient in how we do things, and it's a very, very low-cost camera solution because we see a huge market of cars that now will, for the first time ever, get a camera, just like you are used to getting standards in seat belts, in airbags, and we believe cameras will be the second generation of ADAS systems that will become standard, but you need to do it, as we heard in the economic situation, in a very, very cost-efficient approach. And this is also where this technology really excels. Thank you.
Thank you very much, Manuel. I was amazed of all the competency in this room here. So before we invite you for a drink, I would like to say thank you for coming here. Please fill the network, the Software Excellence Network, with life. Come back to us, connect. Feel free to connect to us, to be connected with anybody else here. We have this big mission, and now we know it's very necessary for everybody here to work together, and I hope you make this come true. Thank you very much for being here, and see you again soon. Goodbye.